A very warm and pleasant morning to everyone present here and to those joining us online. It is indeed a great privilege to welcome you all to the 6th National Level Faculty Development Program on Generative AI and Building Large Language Models, organized by Department of Computer Science and Engineering. This FDP brings together academicians and industry experts to explore the rapidly evolving domain of generative AI. From transforming the way we teach to redefining innovation, generative AI is shaping the future of technology and education. Over the years, our institution has consistently taken initiative to foster academic excellence through workshops, seminars, and faculty development programs. Today, we continue that tradition by offering a platform to learn, collaborate, and innovate. This FTP covers various topics including deep learning, auto-encoders, GANs, transformers, LLMs, prompt engineering, RAG pipeline, vision transformers, and diffusion models. We are truly privileged to have with us a distinguished panel of resource persons who bring a wealth of knowledge and expertise in the field of AI and generative AI. Their contribution to academia and industry have significantly advanced research and innovation in emerging technologies. Now, I request everyone to kindly rise for the prayer song. Thank you for that peaceful beginning. To extend a warm and formal welcome, I now invite Dr. Paul P. Mathai, Head of the Department of Computer Science and Engineering, to deliver the welcome address.
A very good morning to one and all. Respected Principal, Dr. Jacob Thomasvi, Vice Principal, Ms. Dr. Mini PR, Chief Guest of the Day, Dr. Sailesh Shivan, Chief Technical Architect, your Zeros and Ones Kochi, Faculty Coordinators, Dr. Siamol Cherkarote, Ms. Jismi Matthew, and Ms. Nitya Paul, Heads of Departments, Functional Heads, FDP participants from various colleges joining both offline and online, faculty members, staff, and my dear friends. It is with great pleasure and pride that I welcome you to the inauguration of this 6-day national level faculty development program on generative AI and building LLM, organized by the Department of Computer Science and Engineering, FISAT. We are living in a time where artificial intelligence, particularly generative AI, is transforming the way we think, create, and innovate. From text and image generation to intelligent systems that can assist human decision making, the evolution of large language models has opened new boundaries in research, industry, and education. This FDP is a timely initiative aimed at equipping academicians and professionals with the knowledge and skills required to understand and build such transformative technologies. Let me come to my official duty of welcoming you all to this meeting. This meeting is presided over by our beloved principal, Dr. Jacob Thomas V, whose unwavering support and commitment make events like this possible. His leadership continues to inspire and guide us to greater heights. On behalf of CSE department and all those who are gathered here, I extend a warm welcome to Dr. Jacob Thomas V. Welcome, sir. We are truly honored to have with us Dr. Shailesh Shivan, Chief Technical Architect at US Zeros and Ones, Kochi, as our chief guest. A distinguished expert in AI and ML, his presence adds immense value to this program. He is actually a professor at Department of Computer Science, QSAT, and is on a long leave for exploring his expertise in the field of AI and ML. We are especially delighted that he will also serve as the resource person for day one, setting a strong and insightful tone for the sessions ahead. On behalf of all those who are gathered here, I extend a warm welcome to Dr. Shailesh Sivan, sir. Welcome, sir. Now, I would like to welcome our dear Vice Principal, Dr. Mini Pia, to this meeting. Her continuous encouragement and guidance are always helping us to conduct such events. On behalf of all those who are gathered here, I extend a warm welcome to Dr. Mini Pia. Welcome, ma'am. Over the next 6 days, participants will have the opportunity to learn from an exceptional panel of resource persons. Dr. Gina K, Professor Kusat, Dr. Anil Raj J, Data Scientist, IBM Software Lab, Dr. Mohammad Anis V, Director, A1's AI Technosis Solutions, Mr. Nandakishore M, CEO, Conway Innovation, and former Principal Investigator at IIT Palakkad Technology iHub Foundations, and Dr. M.V. Judy, Professor QSAT. Their diverse expertise will undoubtedly provide a comprehensive perspective on both theoretical and practical aspects of generative AI and LLMs. I welcome all of them to this FDP. I extend a warm welcome to our coordinators, Dr. Siamol Cherakarot, Ms. Jismi Matthew, and Ms. Nitya Paul to this meeting. Their dedicated efforts in organizing this program are always remarkable. Next, I would like to welcome all the participants from various institutions who have joined us both offline and online. Your enthusiasm and engagement will make this program truly meaningful. I also welcome all our internal participants, both from CSE department and other departments, who have shown their interest in attending this knowledge sharing FDP. I also welcome all our dear faculty and staff who are present here for this inaugural function. Let us utilize these 6 days not just to learn, but to collaborate, question, and innovate. I am confident that this FDP will inspire new ideas, research, directions, and academic excellence among all of us. Once again, I welcome you all to this enriching program and wish you a productive and rewarding experience. Thank you. Thank you very much.
Thank you, sir, for that warm welcome. And welcome you, sir. Now, I would like to invite our dearest principal, Dr. Jacob Thomas V, whose immense leadership and guidance have turned into the pillars of support and development to every single one of us. I welcome him to address the gathering.
Good morning to each and everybody. Most respected Chief Guest of the Day, Dr. Shailesh Shivan, so faculty in FISAT, Mini Miss, Vice Principal, HOD Paul Sir, Siamal Miss, other faculty coordinators, my dear colleagues. I'm very happy to stand before you in this August gathering. And I congratulate Computer Science Engineering Department for organizing this FDP, 6-day National Level Faculty Development Program, which is in the hybrid mode in Generative AI and building LLM. My earnest request to all the participants is that it should not be confined to the first day. It should be extended to all other 5 days also, and make utilize that facility that is actually provided by the department and FISAT. I had an opportunity to attend one of the leaders' conclave there in IIT Madras in the first week of what is known as first week of this April, and it was attended by about 60 professors from my different IITs, leaders in education sector. They are all saying that education is in a big question mark, or our teaching learning process is in a very chaotic state because of the what is known as the impact of AI. And one professor, Arun Talgru, who is a professor in IIT Madras in chemical engineering, as professor in Tirupati right now, he said AI is underwent intelligence rather than artificial intelligence. That's what he's saying. It is that intelligence from the divine. Okay. So anyway, whatever that intelligence thing is, that we should have the correct. They all said that we should have the correct perspective regarding what actually we want to teach to the students. Another day, Professor Saxena, who inaugurated our Ideal Lab, categorically mentioned that these universities as well as this educational institution will no longer exist by 2040 or 2047. That's what his prediction is. And as per the Blue's taxonomy, the lower 3 layers is well covered by AI right now. So there is no need of what is known as remembering, understanding, apply, and other thing. You have to create. That's the only thing. So my earnest appeal to the dearest faculty members who are sitting in front of me, also attending this thing. We are in a transition period, and the fellows who are actually sitting in front of you may be much higher knowledgeable than us, and intelligence is available in not in fingertips by a third word called that is enough. Now, I mean, tools can be able to pick up that and deliver us what is actually generating this thing. So I once again congratulate Department of Computer Science and urge each one of you to utilize this facility and make it as a translation one. Thank you.
Thank you, sir, for your encouraging words and continued support. We now move to the most awaited moment, the formal inauguration of this FDP. I request our esteemed dignitaries to kindly join us for the inauguration ceremony.
सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतं गमय ॐ शान्ति 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 असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतं गमय।
Thank you, respected dignitaries, for inaugurating this FDP. We are honored to have with us our esteemed chief guest, Dr. Shailesh Sivan sir. He is a distinguished technology evangelist, educator, and a researcher with a rich blend of academic depth and industry expertise. He currently serves as a chief technology architect at US Aeros and Vance, while on academic leave from his role as assistant professor in the Department of Computer Science, Cochin University of Science and Technology. I now invite Dr. Shailesh Sivan sir to deliver the inaugural address.
A warm good morning to all of you. Let me start my speech with a special thanks to Almighty because I'm here today by escaping from a big accident yesterday, a big car crash. So I'd like to thank God Almighty for making me escape from that and being here for this very beautiful event. So respected Principal Jacob V. Thomas sir, our beloved HOD Paul P. Mathai sir, and Vice Principal Binny ma'am, and all the coordinators, faculty members present here, and faculty members in the online platform. So first of all, I would like to congratulate the department and the institution for taking such an initiative to provide an FTP to all the faculty members in and outside this campus, because it is a very relevant need nowadays. We need to update. So I'm particularly a person which is having less experience than most of you, and with knowledge level, and in every aspect maybe I am a junior for you all. But what makes me different is actually the one thing: attitude. So in my school days, I attended a career development course, and at that time, one of the resource person told about what are the good qualities for a teacher. Do anyone know what is the good qualities for a teacher? They said, ask, ASK. The first thing is attitude, the second one is skill, and the third one is knowledge. If one of this is missing, actually we cannot be a good teacher, right? It is essential to have attitude to teach. It is essential to have proper skill of teaching, and we must possess knowledge for effective teaching, right? And when you look into the scenario of current teaching learning practices and the facilities provided by the institution, provided by the government and all, we are actually very much advanced in syllabuses, right? The syllabus is very much advanced. The students is advanced. The facilities is advanced. The only one factor that lacks in the education sector is the teachers, the community of teachers. We don't feel the disruption happening in the teaching learning arena, right? So if we ask ourselves, how many of us are really updating with the pace of technology transformation happening in our current technology space? Genuinely, less than 5% faculty members are updating yourself, right? So this kind of FDPs really provide a platform for updating yourself. So in that perspective, I like to congratulate all the participants for taking a single or for a small step for updating yourself and acquiring knowledge regarding this Gen A and all. See, artificial intelligence is actually not a new technology, right? Do you know at which year it is introduced? AI. It is introduced in 1950s itself, 1956 particularly, right? But the disruptions happened with the artificial intelligence is only after 2020 or 2015, right? And that disruption made a big change in teaching learning practice too. Nowadays, we don't want to be a teacher, right? We don't want to be a teacher because what is the purpose of a teacher? What is the duty of a teacher? To teach lessons, right? But students get these lessons in more better way from online platforms, right? We need not to teach nowadays actually, but we should be their mentors. We should be their facilitators. And being a teacher is very much simple than being a mentor and facilitator, right? We have to know what all things are actually happening in our surroundings day by day. Only that way we can be a mentor for them, right? Because if you look into the knowledge of students who are excelling in this technology space, they are far far better than us, right? We don't know the 10% of tools they know with AI and all, right? Are we smart enough to adapt with education and learning practices currently happening? We are not at all adaptable to that, right? So I wish all of you, this FDP will give a chance for you to think in a different way, to change your attitude from simply teaching to update yourself and challenge yourself to be in pace with the technology transformations. So, congratulating the department and the institution once again, and I'm extending my gratitude for inviting me as a resource person for this particular FTP, and for the other facilities, hosting and all. It is very happy to be in FISAT again and again for different programs. Thank you.
Thank you, sir, for your inspiring and thought-provoking words. Next, let me invite Dr. Mini Pia, Vice Principal of our college, who has assisted tremendously for the welfare of our college and has taken a great effort to maintain and showcase our dignity for felicitation.
Good morning, all. Respected dignitaries on the dais, colleagues, and participants from other colleges. First of all, I congratulate the Department of Computer Science and Engineering for organizing this FTP, especially on this very relevant topic of generative AI and LLM. As Sir said, teaching is now being disrupted by AI, and it's high time that we all update our knowledge properly, because we cannot proceed in this normal way of teaching for very long. And understanding that in our college we have a Center for Future Skills, which has been developed by or installed by the National Skill Development Corporation, and understanding how much teaching is affected even at the school level, we have actually planned a one-day training on the AI tools for teaching for school teachers. And we got so much of response because even the school teachers understand that it's high time they get updated. We got so much of response that now we are organizing 3 such sessions for 3 days, each one day, catering to more than 100 participants from various schools. So that's how AI is actually disrupting, or anyway, you can say that is actually assisting us. It's only that we need to know how we can make use of this. So I heartily congratulate all of you who have registered for this FTP. I'm sure that without improving our knowledge, for us standing in pace with our students will be very difficult. And understanding that you have all taken the time off to register, and hope you'll have a very wonderful learning experience in this 6-day FTP. I wish you all the best. Thank you.
Thank you, ma'am, for your kind and encouraging words. Now, I welcome Dr. Shailesh Shivan sir to accept a token of gratitude and honor. I request our principal to do the honors. Thank you, sir, once again for your presence, guidance, and encouragement. We wish you continued success and achievements in all your endeavors. To express our sincere gratitude, I now invite Dr. Siamol Miss to deliver vote of thanks.
Respected Principal Jacob Thomas, sir, Vice Principal Dr. Mini Ma'am, Head of the Department Dr. Paul P. Mathai, sir, our resource person Dr. Shailesh, sir, faculty members, and participants of the Faculty Development Program. It's my privilege to propose the vote of thanks on this special occasion of the inauguration of our 6 days FDP. First and foremost, I express our heartfelt gratitude to our respected chairman, Shimit sir, for sanctioning this FDP with unwavering and unconditional support. Due to his busy schedule, he couldn't reach here today. Thank you, sir. I extend my sincere thanks to our respected principal, Dr. Jacob Thomas, sir, for his continuous motivation and encouragement. I would also like to thank our Vice Principal Mini Ma'am, who has always been a well-wisher of our department. Her timely suggestions and guidance have been invaluable in organizing this event. My deep sense of gratitude goes to our head of the department, Dr. Paul P. Mathai, sir, the strong pillar behind us, who has guided us right from the beginning and ensured everything fell into place. I extend our heartfelt thanks to our resource person, Dr. Shailesh sir, for accepting our invitation and being the part of this FDP. We are truly grateful for your willingness and share your knowledge and expertise. My sincere appreciation goes to my joint coordinators, Jismi Matthew and Ms. Nitya Paul, for their dedicated efforts in organizing this program successfully. I extend my thanks to the Administrative Officer Vinod sir for ensuring all the basic arrangements and support. Special thanks to the multimedia team for their excellent technical support. I also thank all the heads of departments, external participants, and faculty members for their presence and active participation. Once again, I thank each and everyone who contributed directly or indirectly to the success of this inauguration function. Thank you all.
Thank you, Miss, for the heartfelt words. Now, I request everyone to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. All participants are requested to assemble in front of the stage for a photo session. Dear participants, we will now break for a tea. The FDP session will start in 10 minutes. Kindly seat it on time so that we may continue without delay. A distinguished technology, academic depth, and industry expertise. He currently serves as a Chief Technology Architect at US 001, while on academic leave from his role as Assistant Professor in the Department of Computer Science, Cochin University of Science and Technology. Dr. Shaili Sir hold a BTech in Computer Science and Engineering from Kerala University and an MTech in Computers and Information Science from FISAT and an MSc in Mathematics from University of Madras. He earned his PhD from Department of Computer Application FISAT for his pioneering research on AI techniques for analyzing classical dance. With over 9 years of experience in teaching and research and 5 years in IT industry as senior software engineer, Dr. Shailesh brings a strong blend of theoretical knowledge and practical insight. His expertise spans across key domains of AI and data science, including deep learning, computer vision, machine learning, natural language processing, data mining, soft computing, quantum of computing, and knowledge graphs. As Chief Technology Architect at US Heroes and Ones, he architects end-to-end technology strategies that transform ideas into scalable digital products. He leads AI and ML integration, system design, and platform evolution, enabling teams to deliver robust, high-impact solutions across diverse domains. The forenoon session titled Diving into Generative AI, from AI to Generative AI through Deep Learning, will explore the foundation concepts and evolution of AI towards Generative AI with a focus on deep learning techniques. Following this afternoon session from 2 to 4 p.m. on Generative AI models for image analytics, autoencoders, and GANs, will delve into the advanced models and their application in image generation and analysis. We are confidently today's session will be highly informative and enriching for all participants. With this, I invite Dr. Shaili Sivan to begin the session. Thank you.
So, warm good morning to all of you, all the participants. So, today we have two sessions. First, on the introduction to generative AI, starting from artificial intelligence, then machine learning, then deep learning, and how it is actually converged into Gen AI. Okay, so this is a very essential understanding you need to have. Otherwise, starting from generating AI is actually a foolishness. Okay. So we are having a first session, a in a very layman perspective, we are actually explaining all these things. Okay, very practical oriented and real life examples driven. And afternoon, it is more technical. We are discussing about the very important techniques in generative AI, which is called as autoencoders and gaps, generative adversarial networks. Okay. So as we are having participants in online and offline, I have planned for a hands-on session, but it is not possible through a hybrid mode. So I will be demoing some of the concepts we are discussing, and I will share the codes. You can actually try it by your own. Okay, so that's a way we are actually engaging the session. So we are starting with generative AI, three theories and practices. Okay, so whenever we heard about or when we are listening to the word artificial intelligence, there are a lot of things we are getting connected with this. Artificial intelligence, machine learning, deep learning, Gen AI, LLMs, agents, data science, data analytics, all these things are there, right? But as an enthusiastic person towards this any of this domain, you should thoroughly understand what is happening with all these domains properly and how they are differentiated and how they are related. Okay, so let me begin with artificial intelligence, and it can be viewed as a starting point to LLMs. Okay, starting point to LLMs, which is our main theme. Okay, so, as you can see in the Venn diagram, we have artificial intelligence, machine learning, deep learning, natural language processing, large language models. Apart from that, we can see the Gen AI as one of the subdomain. Then we can see intersection between data science, data analytics, all these things. Okay. So, if I ask you what is the difference between AI and machine learning, the confusion starts at that point itself. One can easily say machine learning is actually a subset of artificial intelligence. One question that make you stuck is, can you tell anything which is inside AI but beyond ML? One thing, one task which comes under AI but which is not a machine learning. The confusion starts from that point itself. Because we are simply theoretically understanding a machine learning is a subset of AI, right? But how significantly we can understand machine learning is a subset of AI, okay? And what all things are there within machine learning other than, sorry, within AI other than machine learning, okay? So the very broad domain, AI. When we are talking about AI, we know we are experiencing this particular technology through different devices, right? To our smartphones, to our smartwatches, computers, right? Laptops, right? Through these devices, we are experiencing artificial intelligence. Okay. So, what is a computing system? What is a computing system, or what you simply call as a computer? It is an electronic device, particularly used to handle data, right? Okay. And it can store data, it can accept data, it can process data, it can output data, right? And if you look into the family of computing devices, we can see the computers that can be implanted in our teeth to the computers that spans across different floors, right? So it's a big family of devices, right? The IoT devices, the embedded devices, mechanical devices, different mechatronic devices, everything comes under what? This computing family, right? And robots, all these things are actually coming under computing family. So, what is the reality about a computing device, or what is the reality about devices comes under computing family? If I ask you a question, are computers intelligent or dumb? Are computers intelligent or dumb? inherently are they dumb or intelligent? Computers are dumb devices. Okay, we can say that inherently they are dumb devices because we have to instruct computers to do any task, right? We have to write programs, we have to execute that program to perform anything by a computer, right? So in that perspective, we can say that computers are dumb devices, right? Yes, computers are dumb. But apart from this dumbness, there are a lot of other good properties for computers, right? That's why it makes a special device to us. We cannot think even a day without computer, right? Can you think about a hospital system without computers now? An education sector without computers? A government office without computers? A bank without computers, right? We cannot even think about a day without a computer, right? So they are very special to our day-to-day life, or they are very impactful on our day-to-day life. Still, it is having the limitation of dumbness, right? With the ability, without the inability, with the inability to have knowledge itself, it is a very special device, right? So how it will perform if it is possessing some kind of intelligence? It will make wonders, right? Or it can work in a magical way, right? That's a simple intuition. So with this intuition itself, people started looking for how can we make computers intelligent, right? From the beginning of the introduction of computers itself, different scientists, different mathematicians are thinking about how can we make a computing system intelligent. As a result of that, different works are there in the literatures. One of the very famous event happened is a conference called Dartmouth Conference. Dartmouth Conference. There, people gathered together, a lot of mathematicians, computer scientists were gathered together, and they started thinking, brainstorming about how can we make a computer think. Okay, not intelligent. How can we make a computer think? Right? As a result of that, they introduced a word called artificial intelligence. And the person who introduced that word is actually called as John McCarthy, right? He's a renowned scientist, right? A renowned computer scientist. So John McCarthy introduced the word artificial intelligence. But even before that, there are some literatures that makes or that tells about how we can make a computer intelligent. But at that time, it is not named as artificial intelligence. Some people call it as thinking machines, like that. Okay, and that work was introduced by a scientist who is known as the father of computing or father of modern computer science. Who's that? Father of modern computer science or father of computing? Turing. Alan Turing. Okay, Alan Turing mentioned a lot of techniques about how we can make a computing system intelligent, right? But the word artificial intelligence was first introduced by John McCarthy itself. Okay, and starting from 1950s itself, as I said, there are a lot of things happening in the domain of artificial intelligence. But if you look into the history, after 1968 or the late 1960s, there's a period called dark age of AI, or it is also called as AI winter, right? Where people thought that artificial intelligence is no longer useful because it struggled with solving a lot of small mathematical problems. Okay, and people were not funding on artificial intelligence research. People are not actually doing research on it. People are not using artificial intelligence. They go behind the mathematical modeling techniques, right? But after a few years, in the early 80s, what happened is someone came up with some new techniques in artificial intelligence, which is called as machine learning, which is called as machine learning. So machine learning again regains the importance of artificial intelligence. The unsolvable problems in artificial intelligence were solved with what? Machine learning, right? So it got a rebirth in 1980s, and down the way we can see that the deep learning were introduced in 2021. We see the chat gpt, which is one of the iconic model of generative ai. Then after that, the agentic ai is introduced, right? A big disruption is actually happening in the technology space with artificial intelligence. See, there is a fact that I did my BTech in 2008-12 period. Okay, and I studied under Kerala University, computer science and engineering. They have actually thrown out this artificial intelligence subject from the syllabus as an obsolete one. They were thinking that it is no longer useful. But what is happening nowadays? They were actually starting new branches in the name of artificial intelligence, right? So this is the change happened in it. That is not a big period. It happened in 2008, and they started new courses in 2018. Within 10 years back, the entire technology space and artificial intelligence become one of the major player in the computer science domain itself, right? And when you think about artificial intelligence based on the capability of AI, we can see that there are three different levels of intelligence. The first one is called as artificial narrow intelligence, and second one is called as artificial general intelligence. The third one is called as artificial super intelligence. Okay, artificial super intelligence. How can we distinguish these kind of intelligence? With the definition, it is very simple. See, super narrow intelligence is something like able to perform only one specific task. Super intelligence is supposed to perform various tasks like a human. The sorry, general intelligence. Super intelligence actually surpasses the human ability, right? So definition is actually very simple. But if one student is coming up to you and asking that, ma'am, can we explore one narrow intelligence system? Can you tell me one example of narrow intelligence system? How will you demonstrate that? How will you make him understand what is narrow intelligence? We will again say a system that is capable of doing only one specific task. Will he get satisfied? No. So how can we make him understand really what is narrow intelligence? Okay, this is where the innovation in teaching should happen. Okay, do you have your mobile phones with you? Yes, can you take your mobile phones outside? Please switch on your camera application, your camera applications. Online participants can also do this experiment. Please take your mobile phones outside, switch on your camera application. Okay, switch to your front cam and look at that camera. Are you able to see your faces, the beautiful faces? Yes, yes. So along with that face and the background, are you able to anything augment around it, anything extra on it, anything, anything which is not present in the scene? A rectangle, right? Or a corner indication? Yes. What is that? Face detection, right? Do you think that system need intelligence for this? From the scene, it should understand where the face is, and it should locate that face and indicate with a rectangle. That system needs an intelligence, right? And this is only doing a one specific task, which is called as face detection. And this is the example of narrow intelligence, right? And one more example I can introduce to you. Can you move to your WhatsApp? Please move to WhatsApp. Okay. Just go to the chat window of one of your favorite person. Any of your favorite person. Yes. Type the things I'm telling now, but dot send. Okay. Hi, hi, comma, space, how, how, space, There, D-A-R-E, there, space, how, space, there, space. The next word I am going to tell you is you. What is the word suggested by your keyboard? Is it you? Maybe multiple words are there, but you will be there, right? Yes? How a system can understand, I'm going to tell you next. I intended to say, how dare you, right? But only even after typing, how dare, the system is intelligently identifying that the next word will be you. So this is what we are calling as next word prediction. What is that? Next word prediction. This is also one example of narrow intelligence. Is that clear? Right? Okay. So when you teach these concepts, try to relate with this real-time examples, then the students can actually understand this concept in a very better way. Right? Okay. So it is not difficult to get these examples. You just take ChatGPT and just ask, can you give some examples, real life examples of narrow intelligence to demonstrate to the students in the classroom? It will take merely 1 or 2 minutes to get that, right? But we are not taking that effort. That's the problem, right? Okay. So narrow intelligence, then general intelligence. What is general intelligence? If you think about general intelligence, as per the definition, it should work like a human. And what is the capability of a human? Human can perform multiple tasks, right? Human can perform multiple tasks like a multitasking system, right? So artificial intelligence also need to perform in that way, but in actual scenario, no exact general intelligence. We don't have an ideal general intelligence like a right? All the intelligence examples we are having is actually a low capable general intelligence systems. Low capable general intelligence system. Example, camera. The AI cameras can actually detect whether a person is wearing a helmet or not. It can detect whether a person is wearing a seat belt or not. It can count the number of people in the vehicle. It can estimate the speed of a vehicle. All these things can be done, right? So it is doing multiple tasks as a single system, right? Or the ideal example can be a humanoid robot, Sophia. Have you heard about the robot Sophia? Right? Sophia can actually wish with you, right? It can sing for you. It can have conversation with you, right? Siri can also be considered as that, but it is only a conversation agent. But when it comes to Sophie, it can walk, it can sit, it can sing, right? A lot of capabilities related to human abilities is there, right? So it is particularly an ideal example of what? General intelligence, right? And when it comes to super intelligence, as per the definition, it is an ability of a AI system which surpasses human intelligence. Human, beyond idea. The intelligence are beyond human capabilities. Okay. And very fortunately, we have not at the age of super intelligence. We need to wait again at 100 or 200 years to attain what? Super intelligence. And even though if we wait for these much years, an ideal super intelligence won't come, right? But have you heard about the giants like Meta, Google, and other companies are starting super intelligence labs? Have you heard about that? These companies already started the super intelligence lab, but their focus is not a general super intelligence. They are focusing on a domain specific super intelligence. We know robotic surgeries, right? Now the surgery is done by robot, but all the monitoring and other parts are done by human. But think about a system, we only need to push the patient inside the operation theater and he will come out after all the surgeries without human interventions. So there what is happening? is actually doing everything like a human, right? Or maybe beyond human capabilities, right? Such kind of super intelligent systems are focused by these companies, right? For a specific domain, self-drive car is not actually a super intelligent system. It's actually there's a there's a big gap between intelligence and wisdom. The super intelligence is actually focusing on making wisdom for systems, right? That wisdom is not at all attainable. That is the truth. Okay, the wisdom is the only ability of a human. But at a certain level, we can actually create this intelligence which is matching with what? Wisdom. That is the goal of super intelligence. Self-driving cars are particularly a simple general intelligence system. Okay, it is nothing beyond human, right? Are you able to see any functionality that comes in a autonomous cars which is showing the ability beyond human? No, right? Right? So such kind of intelligence, but we can see this kind of intelligence in fiction stories and films. The Environ, right? Or the Jarvis in Iron Man movie. All these systems are actually what? Super intelligent systems which replicates the intelligence beyond human. Right? So only in fiction stories and films only we can experience this. In reality, there is no super intelligence. But think about it, an era of super intelligence. We need not to do anything. We only need to sit on the chairs. Right? Have you seen the movie I Robots? I Robots? No? You can see you must see I Robots. The I Robots depicts how the super intelligence age will be. We can see a lot of fatty humans sitting on the chair, just eat something. Everything else is done by AI, right? So such kind of world is not at all imaginable actually, right? And government is taking a lot of restrictions and regulations to not make a system into super intelligence because apart from the advantages, there are a lot of other impacts happening at the other side. Have you heard about the environmental impacts generated by AI? Right? The OpenAI server farms, the places near OpenAI server farms are not having water. All the water resources are now red in color with the copper deposition. People are not able to drink water from the nearby regions of the OpenAI server farms. Right? And what is the system or the domain that makes a huge carbon footprint in your knowledge? Transportation systems, right? But if you look into the statistics, it is actually 25 times lesser than an AI generated carbon footprint, right? So there are a big environmental impact happening in the other side with the involvement of what? Involvement of artificial intelligence. So the government, UNESCO, UNICEF is actually taking a lot of restrictions for creating such kind of intelligence. So hope we can see that domain specific super intelligence very soon, but a general super intelligence system will not come up as fast as we are thinking. Okay, and when when it comes to the intelligence, the artificial intelligence systems, what is the capability of an artificial intelligence system, or how can we define an artificial intelligence? What is the technical definition of artificial intelligence? So if I ask you, are you intelligent? Are you intelligent? Yes, we are all intelligent, right? Okay. So to possess intelligence, what you need? How can we say a person is intelligent? And how will you define the intelligence of a human? decision making. Yes. Anything else? So do you think Eshudas as an intelligent singer? The intelligence is actually reflecting in his modulations, singing style and all, right? Yes. And do you think PT Usha as an intelligent athlete? Yes, right? And few months back, there's a champion from India, grandmaster from India. What is his name? A kid, a 15-year-old kid. Gukesh. Do you think Gukesh is intelligent? Yes, right? So, can you relate these intelligence? All these intelligence are same? No. So, we cannot confine intelligence as decision making, right? So, what is intelligence? Intelligence of a human is the ability to apply his knowledge to solve problems in real situations, right? The ability of a human to apply his knowledge to solve problems in real situations. That problems can be anything. That problem can be a decision making. That problem can be an optimization. That problem can be a creative thought process. Whatever it is, if a human is capable of applying his knowledge, what he have acquired through data and information is what is called as knowledge, right? If he is capable of applying knowledge for solving a problem in a real situation, we can say that he is intelligent. So, what are the two components we need for intelligence? First one is the knowledge, and the other one is the capability to apply it, right? The capability to apply it. So, when it comes to artificial intelligence, knowledge is there, right? Because computers are meant to handle what? Data, right? And the data become information, and the collection of information is actually called as what? Knowledge. The organized informations are known as knowledge, right? And how can we make a computing system able with the help of computer programs? And what is the soul of a computer program? Soul? Logic. And how will you represent the logic? As algorithms, right? As algorithms, right? So, artificial intelligence is actually a branch in computer science that deals with making intelligence to computing devices with the help of data and algorithms. With the help of data and algorithms to make them enable with decision making, optimization, and even to generate contents. Right? Okay. So we can see the examples of AI cameras. What is happening there? It's actually making a decision on whether a person is wearing a helmet or not. Right? Whether a person is wearing a seatbelt or not. So it's all example of what? Decision making. Right? When it comes to Swiggy and Zomato, how they are actually using AI to optimize the distance between a delivery boy, the customer, and the shop to be delivered, right? So there we can see the applications of AI optimization domain. And there also the in Indian Railway. See, as teachers, when you start with an academic year, what is the major struggle you face? The timetable setting. Yes, the timetable setting and the time management, right? Then can you just think about the timetable of Indian Railway? How difficult it is, right? Okay. And how they are actually easily doing it? With the help of AI and its interventions in optimization, right? And what is happening with this Gemini, ChatGPT, Google Translate, Zora, all these things? What is happening? They are generating some contents out of our queries, right? So there we can see the application of AI in content generation, right? So AI is actually focusing on inducing intelligence for computing systems for making the enable with decision making, optimization, and even to generate contents. Right? So, how can we infuse intelligence? That is the question. How can we infuse intelligence? Are we making intelligence in the same way? Are we making intelligence in the same way? If I ask you a question, what is the value of x if x plus 5 equal to 8? 3. Obvious answer is 3. And how did you solve it? You have the knowledge of mathematics from the small classes and you faced a problem here and you apply that knowledge and solve it, right? Right? But if I ask you a question, what is the next term in the sequence? 1, 2, 4. Is it 8? 1 plus 1 is equal to 2. 2 plus 2 equal to 4 plus 3 equal to 4 plus 4 equal to 8. 4 plus 3 equal to, that is also correct, right? Why you are struggling? Can I say is that the lack of intelligence? Sometimes intelligence needs something extra, right? So for each system, we are processing intelligence in different ways. Right? We are processing intelligence in different ways, right? Sometimes we depend upon our visuals for making intelligence, right? How can we understand elephant is a huge animal? Through our visuals, right? How can you distinguish between the voice of Yeshudas and voice of MG Srikumar? Through voice, through sounds, right? How can you understand whether a particular literature is written by M.T. Vasudevan Nair or the other person, Patumedadu Bashir? How can you understand that? Through the text, right? Through the text, you can understand that, right? The way of writing is entirely different. So we need to depend on different kind of data and different strategies for making intelligence, right? Right? So particularly with that distribution, we have several subdomains in artificial intelligence. The first one is actually called as machine learning. The second one is called as speech systems. The third one is called as computer vision. The fourth one is called as natural language processing. The next one is expert system, planning and optimization, and robotics. So these are all several subdomains in artificial intelligence which uses different strategies and different modalities of data for making intelligence. Right? The techniques, as I said, see, suppose you want to detect a face. Okay, suppose you want to detect a face. Do we really need machine learning for that? Do we really need machine learning for that? See, I will tell you one example. Team, can you switch to board? See, if you have a face, okay, it's actually a collection of what? Pixels. Okay. So if there is a face here, okay, there's a face here, we can see this eye as a matrix, right? Matrix of different intensities of pixel values, right? And have you heard about an operation called gradient? What is that? What do you mean by gradient? Yes. If you calculate the gradient of this matrix, you will get another matrix which is having the same size of that of the input matrix. Okay. right? And here, 1 pixel point is actually representing gradient of that particular xy. Gradient of that particular xy. Okay? And gradient is nothing but if you want to find the gradient of this point, you need to understand what is the change happened in the neighbors with respect to this particular pixel. Right? So can you just imagine where is the point we will get the maximum gradient in a face? There's a big transition of grade pixel values happening at eyes. In all other regions, we can see that the faces of all having a same texture, right? But the big change happening at our eyes because it is actually transforming from a black region to white region, right? Now, can you just tell me where the maximum gradients will appear at these 2 points, right? So if you get the maximum points, if you draw a line that connects that maximum regions and taking the midpoint, then take the same distance towards up and trace of that distance toward down. Now, if you draw a rectangle that connects all these 4 points, you will get a face, right? So, face detection is an AI system, but there is no need of learning from data for this, right? This is the answer for the first question. What is coming inside AI beyond ML, right? And this is a very particular technique defined or explained in the domain called computer vision. Okay, computer vision. And in NLP also, have you heard about the finite state machines? NFA, DFA, Mealy machine, Moore machine kind of stuff, right? So in all times, even before the introduction of AI, okay, we can have the features like spelling correction, grammar correction, everything in our word processors, right? How this is happening? These things are happening with that finite state machines. There is no need of learning for that, right? That is also a traditional natural language processing system, right? So in each of this domain, team, can you switch? So in each of this domain, it's have its own techniques, whether it is robotics, whether it is decision making, whether it is expert systems, speech, vision. In speech systems, there are a lot of techniques involved with digital signal processing, right? To separate two frequencies of sounds, we have different filters in signal processing systems, right? So in each of this domain, it's have its own techniques. But what is happening is, see, there is an algorithm to detect a face, right? But if I simply tilt my face to the left or upwards, what will happen? One of my eye will get occluded, right? Right? Then will this algorithm work or not? No. So we cannot rely upon the robustness of the algorithms or the traditional algorithms, right? And most of the cases, the grammar things will be giving wrong indications if you simply use some kind of sarcasms, right? Or if you input a Gen Z language into a system which checks grammars with the finite state machine, it will simply say these are all wrong things, right? Okay. So the robustness and the efficiency of such kind of traditional systems are doubtful and they are inefficient too, right? And how can we tackle that inefficiency? There comes the importance of machine learning. There, what we have to do is we have to collaborate or we have to synergize the techniques from machine learning along with all other domains. So whatever products we are seeing in computer vision or NLP or in expert systems or robotics, nowadays, all these are actually a synergized form of machine learning and its own technique. In that perspective, we can say that the entire artificial intelligence domain is actually dominated by machine learning, right? It is dominated by machine learning, right? Or nowadays we can say that AI is somewhat equivalent to machine learning. Now, if you want to learn AI, you really need to learn machine learning, right? So, have you got the point? Yes. Why the AI, the machine learning become very important? And to relate with this, I will tell you one thing. Suppose you're having a kid at your home, okay? And as a mother, you are telling him a set of rules to purchase or to buy vegetables, right? But as a father, your spouse is actually taking him into the market and he's making experience with how to buy the vegetables. Both are learning, right? One is a rule-based learning, the other one is a experience-based learning. Which one is more efficient? Experience-based learning. So machine learning is actually relying upon that particular thing, and its tagline itself is learn from experience. What is that? Learn from experience. So machine learning is nothing but it is a subdomain of artificial intelligence which relies upon a technique called learn from past experience. Learn from past experience. Okay. So what is this past experience? What do you mean by this past experience? The past experience is nothing but the data. Past experience is nothing but the data. Okay. So what is happening with machine learning? If you look into the techniques within machine learning, we can see that so AI is any technique that makes a system intelligent. AI is any system that makes a system intelligent. But in machine learning, we are focusing on data. We are focusing on data, and we will particularly input this data into a machine learning algorithm. What is that? Machine learning algorithm, right? We will particularly give this data into a machine learning algorithm, and this machine learning algorithm will output something called as a ML model. What is that? ML model. Okay. So this is called as experience. This is called as our experience. And this is our steps of logic to find the model. And model is nothing but it is a pattern present in the data. It is a pattern present in the data. So what we are actually trying to do here with a given set of data, okay, with a given set of data, by using a machine learning algorithm, we are trying to find out a model. Okay. So people are actually confusingly use this machine learning algorithm and machine learning model, but these are two different things. Machine learning algorithm is a step-by-step strategy to find a model from the data, right? So I will give you one example. See, if one is mapped to, this is my data, and the data is composed of two variables, x and y. Okay, so here one is mapped to one, one is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 4 is mapped to 16, right? And finally, 7 is mapped to 49. 49. My question is, what is the mapping of 10? What is the mapping of 10? What is that? 100. So, this is what we are calling as the data, right? And have you heard about a technique in mathematics which is called as curve fitting? Curve fitting, right? There we assume that our model, our pattern that connects y and x is ax square plus bx plus c. We assume that a relationship that connects x and y are ax y equal to ax square plus bx plus c. And finally, with some strategies, we are able to find this what is this a, what is this b, and what is this c. So by following the strategies, I found that here for satisfying this pattern, A should be 1, B should be 0, and C should also be 0. See, we finally found the pattern that connects x and y as y equal to x square. This is what we are calling as our model. So this is our data. This is what we are calling as curve fitting is our algorithm, and y equal to x square is our model. Are you clear with that? Now, what is a machine learning algorithm? What is a machine learning model? And what is the data meant to machine learning? Right? But the question is this data really suitable for machine learning? Do we really need machine learning for this? Can we apply machine learning for all problems? There is no need of applying machine learning for all the problems. Suppose if you give this question to your students in the lab as a part of C programming or Python programming, they will simply write a program, right? They will manually identify a pattern that connects x and y. Then they will write a function to get the x, and they will return the x square as an output, right? Right? So, do we really need machine learning for this? No. That is the point we have to understand. Every problem cannot be solved with or need not to be solved with machine learning, right? But if you are giving this question in another way to students, okay, giving this question in another way to students like this. See, 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 8.9, 4 is mapped to 16.2, 5 is mapped to 25. What is the mapping of 10? Will you be able to tell me now what is the mapping of 10? What is the mapping of 10? No. Right? So what makes this hurdle? Switch. What makes this hurdle? Previously, the relationship between x and y is particularly defined and crisp, right? But here, the first point, the problem is with that, with having an uncertainty, right? The relationship is uncertain in the data. So you have to find problems with uncertainty to solve with machine learning. Otherwise, there is no need of using machine learning for solving it, right? Okay, right? So If you look into the real life scenarios, everything is uncertain. Can you tell me whether tomorrow will be a rainy day or not? Uncertain. What will be the price of gold after 1 week? Uncertain. What is the stock value of Nvidia after 1 week? Uncertain. Will you reach today at home by exactly at 5 o'clock? Is it uncertain? Right? Everything is actually uncertain. Right? So that is why machine learning problems are very much useful for real life scenarios. Right? And the second one is, can we handle every uncertainty with machine learning? That is the second question. Can we solve every problem with uncertainty using machine learning? If you have the data of Cardinia lottery for the past 100 days, will you be able to predict what will be the next day's prediction? No. So every uncertainty is not apt for machine learning. Uncertainty which is showing some kind of hidden patterns are actually apt for solving with machine learning. We cannot say that tomorrow will be rainy or Sunday, but if you see the previous history of past 1 week, approximately we can say that there will be rainy or sunny. With the past 1 month's gold price, I can approximately say that what will be the price of gold after 1 week, right? By looking into the stock prices of Nvidia, I can particularly approximate what will be the stock price of Nvidia after 1 month, right? And why these are all happening? Because there is a hidden pattern, an uncertain hidden pattern is lies inside the data, right? So for applying machine learning, the second problem is uncertainty in it. Okay, uncertainty. I will tell you one more example. See, if I particularly give you a story, okay, and I'm asking you to replicate that story by yourself without looking into it after understanding the context, how many of you will write the exactly same sequence of words? If there are 100 people in this room, I will get 100 versions of that story, right? So that is also an uncertainty, right? But the context is same. All of you are saying the same story, right? But the context is different. So is understanding a text just uncertain or not? Uncertain. But are we understanding the same context? Yes. Why? Because there is a hidden pattern in it. Right? Is that clear? Right? That is why language processing become more suited for machine learning. Right? And the third point, we must be able to generalize that particular pattern through approximation. Okay? We must be able to generalize that pattern with approximation. Right? Here, in the given example, 1 is mapped to 1, 4, 2 is mapped to 4, 3 is mapped to 8.9, 4 is mapped to 60.2, right? We couldn't say that y is exactly the square of x, right? But we can say that y is approximately somewhere very nearer to the square of x, right? So y equal to x square is not needed. Y is approximately equal to x square is what we are finding as a pattern, because that approximation is enough for us, right? See, I will tell you. See, if you start at 8 from your home, okay, and you particularly want to adamantly want to reach the office or the college by 8:45, and if it is 8:46 or 8:44, you will take a leave for that day. Many of you will take leave at each day. How many leaves will be there in a semester? If you're adamantly thinking that you will be taking leave if you're not reaching the college at 8:45. If it is 8:46 or 8:45, I will take a leave. How many days you will be on leave? Most of the days you will be on leave, right? So what we are thinking, we approximately need to reach by 8:45, right? And as mothers, if you're thinking that if someone is wasting the food you're preparing, or if it is not getting enough for a day, I will not make food. How many days you will cook? How many days you will cook? You won't cook at all, right? And for those who are riding the bikes, if you're adamantly thinking that you need to get 40 kilometers mileage for 1 liter of petrol you are putting in your vehicle, how many days you will ride the bike? No, we won't ride the bike at all, right? So everything in our life, 99% of the things happening in our life is actually with approximation. Even how many of you think ChatGPT is exactly giving the correct answer? Are they giving the exactly correct answer? No. It is approximately giving the correct answer, and we are getting convinced with that, right? We human are getting convinced with that. We are not looking for the exact answer. We need what? An approximation, right? That is why we are saying the AI need always an approximation. So for solving a problem, we need to have uncertainty in it. We need to find a pattern in it, and also that pattern must be able to approximate with some models, right? And finally, what is the criteria for that approximation? That approximation should provide minimum error on predictions. Okay, we can actually approximate this scenario in different ways. Like I can take it as y is equal to exactly equal to x square plus 0.1, right? Or I can say that y is equal to x plus 0.1 whole square, right? I can also take y is equal to x square minus 0.2. These are all different approximations, right? What is the correct approximation? One which is giving minimum error on prediction. So finally we come up with what y is equal to x square as a answer. Is that clear? Right? So every time if you are allocating a project or if you are choosing a project for your student, keep in mind that project should have what? Uncertainty, a hidden pattern, an approximation, and that approximation that leads to minimum error. Okay, these much conditions need to be satisfied. So if a student is coming up with a problem, just tell him what is the uncertainty in this problem, right? How can you find the hidden pattern in it? What is the technique you are using for finding the hidden pattern? And what will be the moral of this? If he is able to exactly explain these things, you can clearly understand he is having the understanding of that problem. Otherwise, he is actually taking some products from the JIT and giving it into ChatGPT, and he is simply saying some content that got from ChatGPT, right? So to ask this question, first we have to get equipped, right? That is the point I am again saying we have to get equipped with this. Okay. So hope this is clear for you, right? So are you now able to distinguish between AI and machine learning? Yes? So how will you say that? Anyone? Anyone grab the mic? I'm just asking your perception, not the answers. Anybody? Anybody? ഇത്രയും നേരം കേട്ടിട്ട് what you can understand about AI and machine learning. If someone is asking what is the difference between AI and machine learning, how will you answer it?
Any technique that makes system intelligent is AI, and machine learning is based on data experience. Focus on data experience. Yeah. Susan.
So I think we have to give a clap for Susan, ma'am. Right? This is exactly correct, right? Anything, any technique that makes a system intelligent can be called as AI, right? And particularly, there are different strategies in AI. One particular strategy which relies upon past experience, that is data, is actually called as what? Machine learning, right? Anybody, can you distinguish between machine learning algorithm and machine learning model? Machine learning algorithm and machine learning model. Maybe you have taught machine learning, right? Somebody? What is the example you are giving to the students about a model and an algorithm? I got a very relatable example from a student. She explained the same thing in a way that the ingredients are the data, the recipe is the algorithm, and the final food is the model. It's correct, right? We are using recipe to get the food from the ingredients. So the ingredients is the data. We are applying recipe on that. You will finally get the food as a product, right? Okay. So now tell me what is a machine learning algorithm and machine learning model. Hmm?
Steps for taking to get an output. That step is known as algorithm, and the product output is the machine learning model.
Lena, lead for a clap for Lena, ma'am. Yes. So the steps we need to build a model is actually machine learning algorithm, and that model is nothing but it is the pattern we are try getting out from the data, right? And keep in mind the pattern or the model is not only the equations. Sometimes it will be a set of rules. If rules can be a model, right? And sometimes it can be a decision tree. A tree-like structure can be a model. Okay. Sometimes the data itself become a model. That kind of machine learning algorithms are actually called as lazy learners. Lazy learners. There we need not to find any particular equation or pattern or something like that. We keep the data itself as a model. That is what we are calling as what? Lazy learners. Lazy learners. Okay. So hope you have got a clear understanding of machine learning, right? Right. And when it comes to machine learning, there are a lot of family of algorithms explained based on different theoretical strategies as well as different real life foundations, right? So one which work with information theories actually is decision trees. Okay, one that we can depict with our human nervous system is actually called as artificial neural networks. Okay, one we can relate with probability and statistics is actually called as naive Bayes. Okay, so these are all algorithms, the machine learning algorithms, the strategies to fight the model based on different theories and foundational principles, right? And they can actually do the same thing. The classification can also be done with neural networks, support vector machines, decision trees, KNN algorithms, different family of algorithms do the same thing in different ways, right? And what is actually different there? Their foundational principles are different. Okay, so if you look into such kind of families, I said about the AI window, right? AI window. One which gave a hand to AI to again get a rebirth is actually the support vector machines. Okay, the neural networks failed most of the times, so they thought of there is no need of digging up with neural networks. Okay, at that time, someone introduced a new algorithm called support vector machines. Okay, that gave a rebirth to the artificial intelligence domain itself, right? But after that, there are a lot of interventions happened in neural networks itself. The neural network started doing very efficient thing in a very efficient, very complicated thing in an efficient way. Then we have introduced with deep neural networks. So what happened is the entire machine learning domain was taken up with neural network. Okay, taken up with neural network. Okay, so we always say this artificial neural network family as one of the prominent family of algorithms in machine learning. Okay, one of the prominent family of algorithms in machine learning. There are so many other algorithms, but this particular domain is called as what? One of the prominent family of machine learning algorithms, right? And the core of the artificial neural network domain is nothing but see, it depicts the human neurons or the nervous system, right? A human neuron is actually having different parts. One is called as the dendrites, the other one is actually called as the nucleus, then the axons, the synapses, and all, right? Okay, so if you relate a neural network with an actual neuron, which is called as a perceptron. What is this? Perceptron. A perceptron with a simple neuron. The dendrites are the inputs. The dendrites are the inputs, x1, x2, etc. up to xn. The point where we input x1, x2, x3, etc. up to xn. Right? And there are something happening with chemicals in the cell body. In the cell body, there are some chemicals that manipulate the signals we are receiving through dendrites, right? So the cell body is actually replicated with the weights W1, W2, etc. up to Wn. Okay, these things. This W1, W2, etc. up to Wn. So the inputs are getting manipulated with this weights, right? And finally, that signals are getting processed by the nucleus, right? That particular signals are processed by the nucleus, and that nucleus is actually happening in the sigma, right? Perceptron body, right? And this axon can be related with what? The output neuron. See the output neuron Y. Is that clear? So particularly the neurons are getting depicted as what? An artificial neural network model called perceptron. What is that? Perceptron. And why we need to concentrate on this artificial neural network nowadays? See, have you heard about the Nobel Prize in 2024 in physics and chemistry? The persons who got, we computer science people celebrate this a lot because in physics, both in physics and chemistry, they awarded this Nobel Prize for Geoffrey Hinton and John Hopfield for the invention of artificial neural networks in enlightening the physics experiments. Similarly, in chemistry also, a person who found graph neural networks for protein folding problem got the Nobel Prize. So it's not only a matter of computer science. It's actually a domain that accelerate all other scientific and engineering domains, right? So that is why we are concentrating on artificial neural network, and this is what we are calling as a perceptron. What is that? A perceptron. But as I said, in 1969, I said one problem arises, right? In 1969, the perceptron model actually struggled with solving a simple mathematical problem of XOR gate. The XOR gate is simply taking some inputs, a high and low voltage, right? And it should debit like for 1 1 it should be 0, for 0 0 it should be 0, for 0 1 it should be 1, for 1 0 it should be 1. This is the output we are expecting. But at any cost, the perceptron will not give this output. It will always make mistakes when trying with this data. That is the problem made the AI winner. What is that? AI winner, right? And after some years, see, if you look into the history, the Minsky and Patrick solved the XOR problem. Okay, sorry, found the XOR problem, and the Jeffrey Hinton and his team came up with a particular architecture called multi-layer perceptron. What is that? Multi-layer perceptron that solved the problem of XOR gate. Right? That solved the problem of XOR gate. And after that, in 1995, someone introduced the backpins, introduced the support vector machine. Thereby, people started again using artificial neural network for solving scientific problems, scientific and engineering problems. Then in 2010, they introduced what? Deep neural network. Okay. After that deep neural network, there's a big transformation happened in the area of artificial intelligence. So, what is this multi-layer perceptron? A multi-layer perceptron is nothing but it is a network of perceptrons connected in a feed-forward network. Connected as a feed-forward network. Okay. And it can actually receive the inputs as the perceptron receives. It can also give output as perceptron. But in between that inputs and outputs, there are different set of layers, right? That layers are actually called as hidden layers. Okay. And what is the need of that hidden layer? The hidden layers are capable of handling the non-linearity in the problem, right? The non-linearity in the problem. So how we are actually utilizing this multi-layer perceptron? See, suppose you want to detect the given image as Nile, you will simply take all the pixels. See what how many pixels are there? 784 pixels are there. We are giving that directly into a multi-layer perceptron, which is having how many inputs? 784 inputs. How many hidden layers? In that structure, how many hidden layers? There are two hidden layers. And how many output? How many neurons in the output layer? Is it 9 or 10? 10. Right? What is that? 0 to 9. Right? We have to predict the given images 0 to 9. Right? So thereby, it is actually handling the non-linearity problem. Are you really understanding what is non-linearity? No? How many of you are understanding non-linearity? Yes. I will explain it. See, suppose we are having an AND gate, okay? AND gate. What is the input for the AND gate? Ma'am, we need to switch X and Y, X and Y, right? For 0 0 it's 0, for 0 1 it is 1, for 1 0, oh sorry, 0 0, for 1 1 it is 1. This is our data, right? And if you visualize this data, we can see that for 0, 0 it is 0, for 0, 1 it is 0, for 1, 0 it is 0, for 1, 1 it is 1, right? And how will you model this perceptron? We have to keep a perceptron to x and y, right? X and y. We need to give this x at this point. We need to give y at this point. And there is something called a theta here. Okay, just understand that is theta. And you are getting an output y. And here are two waves, W1 and W2. Right? So if you see this particular perceptron in a mathematical way, what is this y? Y is nothing but it is W y is equal to W1 x1 plus x plus W2 y plus theta. And can you relate this equation with something? If you visualize this equation, it is in the form of y is equal to ax plus by plus c, right? What is that? Equation of a straight line. So if you change any value for a and b or c, it will be a straight line. It will be a straight line. So for AND gate, we need a straight line, right? To particularly separate zeros and ones, we need a straight line, right? For OR gate also, this will be 1, this will be 1. We are actually needed another straight line, or that straight line can be like this. Any of the straight line is apt, right? But the question is, for XOR gate, if you visualize this XOR gate, this is 0 and this is 0, and these 2 points are 1. The possible straight line is W1 x plus W2 x2 plus theta equal to y. Right? The possible model we have is a straight line, and by adjusting W1 and W2 and theta, will you be able to find a straight line at any cost that separates the zeros and ones? If you do any straight line in this plane, it will not separate what? The zeros and ones. Right? So we can say that this problem, this XOR problem, is not linearly separable. What is that? Not linearly separable. And why it is not linearly separable? It is having the non-linearity problem. What is that? Non-linearity. Because with a linear surface, whether it be a line or a plane or a hyperplane, we are not able to tackle this kind of non-linear problems, right? So there they introduce the multi-layer perceptron, and that multi-layer perceptron is actually solving the problem of non-linearity with the introduction of what? This hidden layers. Okay, can you please switch with this hidden layers? Is that clear? Right? So this is the secret. And how this hidden layers are actually handling non-linearity is another story. It will need another 3 or 4 hours to explain it. So I am skipping that part. Just keep in mind, multi-layer perceptrons are capable of handling non-linearity. And one of the secret behind that non-linearity handling is the backpropagation learning algorithm. What is that? Backpropagation learning algorithm. Inside that backpropagation learning algorithm, it uses a very important optimization technique called gradient descent. Okay, right? See, these things are actually very easy to understand, but unless you are not able to properly understand the basic mathematical concepts. It is very difficult. If I ask you, what is the concept of limit of a function? What do you mean by limit of a function? What happens in the sense? If what we can understand from a statement for a function f of x is equal to 2, f of x is equal to x square, there is a limit at a point c. Significantly, if I ask you, what is the equation of a line? What is the equation of a line? Y equal to mx plus c, right? What happens if you change y, m and b? What is the significance of m and b? We say it is slope and intercept, right? But what is the significance of this m and c? What is the idea of derivative? Why the derivative of x square is 2x? What is the difference between a gradient and a derivative? What do you mean by partial derivatives? See, these are all not higher concepts, right? These are all we are studying in our either plus 1, plus 2, or in 8th standard, 9th standard, 10th standard, and we will cover all these things in our beta classes, right? But we are still not able to relate with this real life, or we are not significantly understanding the importance of this concepts in a practical way, right? I will simply show you an example. See, how many of you taught linear regression in the classes? Anybody? Linear regression as a part of machine learning or data science? No? Yes. See, and why the linear regression is modeled as beta 0 plus beta 1x? Why it is not ax plus by plus c equal to 0? That is also a line, right? Why it is modeled as beta 0 plus beta 1x? Did you ever see this application? Anyone? Any of you? No. Not it out. This is a very useful and important application. This is called as desmos.com. Okay? And the y equal to mx plus c. This is the equation of a line, right? With the value of m as 1, c as 1, you can see a line over here, right? What will happen if you manipulate m and c? And why this manipulation is important? What is the idea of linear regression? With a given set of data, you need to align our line in such a way that the error between the line and the projected value should be what? Meaning, right? And what do you mean by aligning a line? We have to adjust the line, right? And how this adjustment happen? See, if you change this m, it will get a rotational freedom, right? And if you change the value of c, it is actually getting a translational freedom. With this translation and rotation, you can align your line in any direction. How many of you teach this c and m in this way? If the students are getting this idea, they are very easy to connect with what? linear regression, right? So make use of such tools. There are a lot of tools. Maybe the maths teachers will learn that. Graphics പഠിപ്പിക്കുന്ന ടീച്ചേഴ്സ് മെക്കാനിക്കൽ ഇല്ല സി നിങ്ങൾ ഈ കോഡിംഗ് സെക്ഷൻ ഇതുവരെ അണ്ടർസ്റ്റാൻഡ് ചെയ്തിട്ടുണ്ടോ വാട്ട് ഇസ് ദാറ്റ് കോഡിംഗ് സെക്ഷൻസ് പരാബോള ഹൈപ്പർബോള സർക്കിൾ ഓൾ ദീസ് ആർ ഫ്രം ദ സെയിം ഫാമിലി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താ മനസ്സിലാക്കുക These are all part of conic sections എന്ന് പറഞ്ഞാൽ എന്താ മനസ്സിലാക്കുക ഇത് നമുക്ക് അണ്ടർസ്റ്റാൻഡ് ചെയ്യാൻ ഭയങ്കര എളുപ്പമാണ് there is something called GeoGebra 3D GeoGebra 3D okay see കണ്ടോ are you able to see this കാണാൻ പറ്റുന്നുണ്ടോ is it possible to see yes see this is what we are calling as a hyperbola right and how this hyperbola is formed by changing the orientation of this angle of inclination see ഒരു പോയിന്റ് കഴിഞ്ഞാൽ this hyperbola becomes what? A circle okay the axis of conics axis of the cone is actually making a perpendicular angle with the plane of cutting it becomes a circle if it is more than 0 less than 90 it will be a parabola if it is more than 90 it become a hyperbola see think about a situation our plus 2 teachers are teaching this concept in this way how easily we can understand this after instead of this how we are actually learning the equation of circle is x square plus y square equal to r square parabola is y square equal to ax plus b the ellipse is actually x square plus y by a square plus y square plus b square equal to 1 what is the need of learning all these things in this way right so in this machine learning and AI itself we can do a lot of experiments like this with tools and one of the other important tool is seeing theory you can actually visualize all concepts of probability and statistics with that seeing theory SEEING THEORY theory seeing theory okay so the gradient designs can also be understood with this understand in this way but as I said it need again 2 or 3 hours to explain all these things from the very basics of limits to partial derivatives if you understand that concept it is very easy to understand what gradient design and you can do a lot of magic with this we can actually tweak these equations in a bit easy way then you can see a big change in the neural network behavior you can actually publish a lot of papers with it. Okay. So try to learn this core mathematical parts, then you can apply these things in a very easy way in teaching as well as in research. Okay. So hope you have understood a very surface level understanding of neural networks, right? And as I said, in 2010, the neural networks are emerged as what? Deep neural networks, right? And what is the peculiarity of deep neural network? What you can observe from this figure? Both are multi-layer perceptron, right? Both are having inputs, outputs, hidden layers. And what is the difference you can observe from this? The more number of hidden layers. So as I said, hidden layers are particularly intended to handle what? Non-linearity. So what is the purpose of increasing number of hidden layers? It can handle more complex problems, right? It can handle more complex problems, right? So the hidden layers are actually giving a capability to think more, right? So more number of hidden layers implies what? More capability for thinking, right? More capability for thinking. This is a very layman perspective explanation. But we can actually relate the concept with this. Okay? And particularly, you can say a neural network as a deep neural network if the number of hidden layers are more than 3. The number of hidden layers are more than 3. Right? But this is not one aspect that makes a neural network deep neural network. There is one more thing which is called as automatic feature extraction. What is that? Automatic feature extraction, right? In automatic feature extraction, what we are actually doing is for any machine learning pipeline. Okay, for any machine learning pipeline, there is something called as feature engineering. Feature engineering, and feature engineering is one of the major stage in machine learning. If you are losing clarity in feature engineering, your entire pipeline of machine learning will collapse. So the performance of the machine learning models are directly depending on what? The feature engineering part. And the name is very simple, the feature engineering. We are engineering the features, right? But it is not as such easy. Okay. Feature engineering includes 3 stages. The first stage is called as feature identification. The second one is called as feature representation. And the third one is called as feature extraction. Right? In feature identification, we are focusing on what all features we need to get from the data. Right? And in feature representation, we are focusing on how to represent these features as numerical values. Right? How to represent these features as numerical values. And the third stage, how can you extract these features as numerical values from the original data? These 3 stages are difficult. I will tell you the complexity with some examples. Suppose you want to handle some images of fruits. Okay, 2 category of fruits are there. A set of images of apple and set of images of banana. Apple and banana. Okay. And what are the features you can think about to distinguish between apple and banana? Shape, color, texture. Right? Shape, color, and texture. But when it comes to apple and strawberry, maybe the shape and texture, color won't work, right? Again, what about apple and tomato? Texture is also almost same, right? If you zoom in and zoom out, size is invariant, right? When it comes to Mammootty and Mohanlal, what are features you will identify? Did you ever get a chance to understand what anomaly is happening with an X-ray? You see an X-ray, will you be able to understand what is the anomaly in it? Not X-ray. If you get a CT scan image, no, but a doctor can do that, right? See, by listening to the songs sung by this idea star singer participants, have you ever found a fault in their singing? Did you ever find a fault in their singing? No. But the judges are giving a lot of mistakes, right? How it is happening? They say രാഗം പോരാ ശ്രുതി തെറ്റിപ്പോയി എന്നൊക്കെ പറയില്ലേ but we are not able to even understand what is Shruti and Ragam, right? Right? So, what is the major difficulty in that? The domain expertise, right? The feature identification itself need a big understanding of the domain. So that part is difficult. Now, just came to the example of apple and banana. How will you represent this color, texture, shape as numerical values? Color, we can have an idea. RGB values can be considered. How do you represent a shape as numerical value? Every shape need to be represented as a fixed set of values. And it should be different for different shape. How will you do that? Again, how will you represent texture using a numerical value? We are stuck. Right? So the feature representation is again a hurdle, right? Now I would say the shape can be represented as hue moments. What is that? Hue moments. If you extract the hue moment of a shape, it will be same for all the shapes. It will be different for different shapes. Again, how will you extract this hue moments from the image? See, the three stages are difficult. Identifying the features, representing the features, as well as extracting the features. All these phases are difficult, and this makes the entire feature engineering a big problem in machine learning, right? And that big problem was mitigated by deep neural network. That is what we are calling as automatic feature extraction. Is that clear? We need not to explicitly do any kind of feature engineering in the case of deep neural networks. The neural network itself is having a dedicated part which is capable of identifying, representing, and extracting the relevant features from the inputs and performing the rest of the machine learning part. Right? So these are the two important properties you need to understand when think about deep neural networks. The first one is deeper way of thinking, and the second one is automatic feature extraction. Is that clear? Yes. Now, mostly we are handling complex data types with deep neural networks. And one of the major complex data type is spatial data. What is that? Spatial data. Okay. And what do you mean by spatial data? If the unit information need to be arranged to get the entire information of the data, then it is actually called as spatial data. That is, if you get a unit information, the correlation between the neighboring informations is very much important to understand the entire context. Right? See, this is an image. Okay? This 784 pixels is actually representing an image. But if you're simply getting that 784 pixels in a bag, and I'm telling that this is an image, will you be able to understand what is the context of that image? No. To understand the context of that image, all the pixels need to be arranged in a row column fashion as a grid. Then you can understand that entire 784 pixels are representing a context, a numerical value 8, right? So the unit information need to be arranged in a specific way, so that we can get the idea about the correlation between each pixel or each information with the neighboring pixels, neighboring information, and together this form the context for the entire input data. Then it is called as a spatial data. So whenever there is a spatial data, to handle that spatial data, we have this dedicated kind of neural network called convolutional neural network. What is that? Convolutional neural network. So whenever you think about images, to solve the problems with images, you can go for convolutional neural networks. Is that clear? Yes. So the convolutional neural networks are the primary solution for handling spatial data. Right? So whenever there is a problem involved with spatial data, you can think about what? Convolutional neural network. Okay? And the next, at this convolutional neural network, we can do the classification. You know what is a classification problem, right? A classification problem, a localization problem where the exact object is present, then the object detection, the localization built on multiple objects are called as object detection, then segmentation, instant segmentation, semantic segmentation. All these things are the applications of what? Convolutional neural network. We can tweak convolutional neural networks in different ways to handle this kind of problems. Okay. And the next kind of data is temporal data. What is that? Temporal data. I'm telling you that I'm thinking about a sentence in my mind, and that sentence includes the words I, terrorism, India, love, and hate. Can you tell me whether I'm thinking about a positive sentence or a negative sentence? Is it a positive sentence or a negative sentence? If I'm thinking like I love India, I hate terrorism, that is positive. But in a way, I love terrorism and I hate India, that is negative. The unit information is same for both the sentences, right? So what makes the difference? The sequential arrangement of the unit information need to be in a particular way. Then only we will get the entire context, right? Such kind of time-dependent arrangement of informations to enter for getting the entire context is actually called as temporal data. Okay, temporal data, right? See, think about a music file. Suppose you have an MP3 file, and you are playing that MP3 file by toggling different parts of that differently. You will cut the music files into 1 second or 5 second, 5 second, 5 second clips and playing it randomly. Will you get the true essence of music? No. Right? And can you just think about the DNA structure? Right? If you look into the DNA structure of human and monkey, it is around 96% similar. So you cannot simply switch at A and G, or you cannot simply swap that A and G. That will entirely change the behavior of a particular organism, right? So that arrangement is important, right? Also the textual data is also a sequential data, right? So all this type of data is actually called as what? Temporal data. What is that? Temporal data. And to handle temporal data, there is something called RNN architecture. What is that? RNN, recurrent neural networks. Okay, recurrent neural networks. Okay, so recurrent neural networks are the kind of neural networks which can tackle the temporal dynamics within the data. Right, temporal dynamics within the data. And this can be used for sentiment analysis, text summarization, question answering, machine translation. There are a lot of use cases for this. The heading is different. Deep learning for not vision, which is NLP. Okay. So Again, there is something called spatio-temporal data. Have you heard about that? Spatio-temporal data. An example of spatial-temporal data. Yes. See, if you're getting into a living room, and one of your cousin or kid is actually watching a movie, and the scene is now paused, and you are seeing a scene where two people are there. Okay, one is having a knife in his belly, and the other person is holding that knife. Can you tell me the person holding that knife is a culprit or a savior? Is he a murderer or a savior? We are not able to decide it, right? What we need? We need the frames before and after the current scene, right? So there is a temporal dependency as well as what is inside in each scene is also important, right? So there is a spatial importance. So such kind of data is actually called as what? Spatio-temporal data, right? So we can handle spatio-temporal data also with what? Deep neural networks, okay? And the very new kind of data we are handling with deep neural network is that graph, okay? Graph data, and we can have a very particular kind of neural network called graph neural network for handling graph data. And what are the problems that can solve with graph neural network? We can do the graph classification, node classification, link predictions, community detection, graph preparing, graph generation. Okay, so these are all different kind of problems that can be handled with graph neural network. If you are very keen in doing some research in a new area, this is a very apt area to choose it. Okay, we can model many real life situations with graph neural networks, and there is not much research is actually happening in this direction. Okay, so there is a space to explore with graph neural network. Okay, see, I will tell you one example. Have you heard about the flood prediction? Flood prediction. Flood prediction means we have to predict the chance of flood in a particular location, right? And mostly, when you think about modeling that problem, we will consider what? The different geographical and atmospheric conditions of that particular place. And with that, we will predict whether there is a flood or not alive. But do you really think the geographical conditions of that place and the atmospheric conditions of that place alone decide this decision? Because we are having flood in Kutanadu because of the rain in Idiki, right? Just think about it in a very simple way. So, do you really think only with the data in a particular place we can predict the flood, right? So, we need to have a link between the current place you are focusing on with the neighboring places of that particular region, right? So, to tackle that problem or to model that problem, we need a graph, right? We really need a graph, right? Then, what is the neural network you need to adapt? The graph neural network, right? So think in this direction. If you're getting a problem, try to find the possibility to model it as a graph, then try to utilize what? Graph neural networks for solving that problem. Okay, right? And see why I have gone through all these things. Because to step into generative AI, you need to have a thorough understanding of what we have discussed so far. So take this as an opportunity to realize yourself, to get in this domain, try to cover all these topics we have discussed in this session, okay, to get a proper clarity on what? Generative AI. Because the generative AI can be placed inside deep learning only. So you need to learn AI first, Then you need to learn proper understanding of machine learning. Then with deep learning, then only you can actually come to generative AI. Okay, right? So generative AI in a very simple perspective, I am just explaining. Okay, so in most of the tasks we explain with machine learning or deep learning, it is actually a kind of discriminative process. Whether it is a classification or optimization, whatever it is, these are all a discriminative task. Deciding whether a person is wearing a helmet or not, whether a given text is positive or negative. All these things are what? A discriminative thing, right? We are deciding something based on the input, right? So such kind of AI is actually called as discriminative AI. What is that? Discriminative AI. Sometimes people say it as a predictive AI, but the correct word is discriminative AI. But there is a counterpart for this, which is called as generative AI, where instead of making a decision, we are generating some outputs based on the inputs. Okay, instead of making a decision, we are making an output based on the input. So this is an example. If you are giving the image of a puppy and deciding whether it is a dog or cat, what is that? Discriminative AI, right? Instead, on giving the image of a puppy, you are trying to generate what will be the appearance of that puppy after 5 years, how it look like after 5 years. So what is happening? It is not a decision making. Instead, we are generating some contents based on the input, right? That is particularly what a generative AI model, right? And similarly, for text, on giving a particular text, we are classifying it as food related or sports related or politics related document. What is that? Discriminative, right? On giving a particular document, we are actually creating the summary of that document, generative task. Is that clear? Yes. So, how generative models works? Okay, how generative models works? And to create the generative models, we are having the encoder decoder model, generative adversarial networks, transformer architectures, vision transformers, and diffusion models. See, if you look into the schedule of the entire FTP, you are covering the entire space in generative AI. Okay, the first day we are covering encoder decoder model and generative adversarial networks. Second day, I think we are dealing with transformers, right? Gina, this is anything. And the third day, the advanced topics in attention transformers, that is LLMs and prompt engineering, then RAD. And one person, Nanda Kishore, is actually taking the vision transformers and VLMs. And Judy Ma'am is actually taking the diffusion model. These are the best resource persons you can ever have in each of these subjects. Okay, so try utilize them. Now try to keenly understand the concepts from them, because other money you can actually go further. Okay. So the encoder decoder model, we are actually going to discuss this thing in a very detailed way in the afternoon session. Still, I will give you a brief. The encoder decoder models are nothing but, see, we have an encoder part and a decoder part. Okay. Suppose you want to deal with images. What will be the encoder and what will be the decoder? Whenever you think about images, who will help for you? CNN. So the encoder will be a CNN, and if the output is also image, the decoder will also be a CNN. Right? If you are thinking about text, there's a query, are you free tomorrow? And you need to generate, yes, WhatsApp. What is the input? Text. What is the output? Text. So what should be the structure of this architecture? Encoder should be an RNN. Decoder should also be an RNN. Is that clear? Yes. And can you just think about, see, these are all different kind of computer vision applications of encoder decoder architecture. If you have an image, you can make it the segmented, right? You can make a noisy images into denoised one. You can super resolution can be done with encoder decoder, low resolution to high resolution. You can do the colorization, right? See, we will discuss in the afternoon session how all these kind of architecture can be built with encoder decoder networks. Okay, now with the text, we can translate from one language to another language. We can summarize one text to another text. We can actually create a question answering system. All this with what? Encoder decoder models. And maybe we can have hybrid models too. See, think about this task. We have an image as an input and text as an output. Can you think about the architecture? What should be the encoder? A CNN should be the encoder. What should be the architecture in the decoder part? It is an RNN because from images to text. And in the case of image generation from text, inverse. Input should be RNN, the output should be CNN, right? There is something called a visual question answering. Have you heard about that word, visual question answering? You can give a pair of input and a text together, and you can have an answer at the decoder. So, what is the encoder? We need it here. There should be a parallel architecture with RNN and CNN in the encoder, and at the decoder we need a RNN. Is that clear? So you can think about the architecture with the use case itself, and it is very, very easy to build this kind of encoder decoder models. Okay. And the next one is actually generative adversarial networks. This is another kind of generative AI model, particularly used for images. See, maybe you have seen this in Instagram. The entire Godfather movie characters are generated with what? Malayalam characters. And you heard about the FISAT? You can upload your images and change the age, right? And have you heard about deep fake? All these things are actually outcome of what? Generative adversarial network. So it is actually a game theoretic model. We can actually explain the concept in the afternoon session. Okay. And with GANs also, see, we can do a lot of things from semantic segmentation to actual outputs, from labels to faces, from black and white to color, from edges to photos, from daylight to night. This kind of applications we can done. Any pair of transformations, image to image transformation can be done with this. And one more point I want to tell you, see, this kind of image to image application, right? Image to image encoder decoder models are actually called as pix to pix models. What is that? PIX to PIX. And encoder decoder model for sequential data is actually called as sec to sec. SCQ to SCQ. Okay, SCQ, sec to sec. Sequence to sequence. Pix to pix and sec to sec. And we have something called transformers. Transformers are the architecture that made a big change, and we are seeing that output of transformers are in the form of ChatGPT. So transformer is actually an architecture with encoder and decoder, right? But the peculiarity is that we can actually use this transformer architecture encoder alone and decoder alone. Okay, that encoder part of transformer is called as BERT. What is that? BERT, BERT. Okay, and the output, the decoder part of the transformer is actually called as GPT. Okay, both are actually called as language models, but the one is the BERT is actually a masked language model (MLM), and the second one, the GPT, is actually called as a large language model. You are getting a detailed explanation of this LLMs on Gina Ma'am's class, so I'm just touching up these things. Okay, so this is the secret behind ChatGPT and other Gen AI models. Now you are experiencing the transformer models. And there's a version of transformers, as I said, GANs are mostly for images, right? But transformers are mostly for textual data. And there is a image counterpart for this particular transformers, which is called as vision transformers. What is that? Vision transformers. Okay. And this is an encoder only transformer. This encoder part. The BERT part is only used in vision transformers. And have you heard about the DALI, DALLE, DALI by OpenAI, image generation? The secret behind DALI is actually called as diffusion model. Okay, diffusion architecture. So these diffusion models are very much popular nowadays for image related generations. Okay, diffusion architecture. The core idea is there is two phases in diffusion model: the forward diffusion and the reverse diffusion. In forward diffusion, what we are doing is the input image is actually transformed into some unrecognizable form, which is called as a latent representation. Okay, latent representation. Then from that latent representation, we will provide a reverse diffusion process which generate the output we want. So if you have a noise in the X0, after the reverse diffusion process, the inherent noise will also get removed from the actual image. Okay, so this is how the diffusion models are working. You also have a diffusion model session with Judy ma'am. Okay, and finally, as I said, the transformers, we have GPT. The GPT is transformed into GPT 2, 3, instant GPT, and chat GPT we have. And now we have chat GPT 5.0, I think, right? And these are all different kind of popular Gen AI products we can use for different application. And what is the Gen AI tool now you are using for teaching learning practice? ChatGPT. But I would recommend you have to use Claude, Claude, Claude. Okay, Claude is one of the efficient model nowadays we can rely upon. It will generate very beautiful. I will show you. Have you ever generated PPT using ChatGPT? Did you get proper structure? No, I will show you an PPT that I made of. See, this is one slide I made using Claude. See how beautifully it is actually created. It took 5 minutes to generate this. So try to use Claude as a tool for generating things. Then something else called Gamma, GAMMA. But that is for actually creating some realistic images in this. But Claude is particularly focusing on the contents you need to include in the slide. Okay. So try to use this cloud. And finally, these are some theoretical steps. I will share the slides with you. You can read through this. Okay. As time is running beyond our schedule, I'm just winding up this thing now. So if you have any questions, you can ask. Otherwise, you just need to prepare it. In the beginning of afternoon session, we can get a clarification on the doubts. Okay. So we have to close it by 12:30, right? Now it is 12:45. I don't know whether you are bored or something. Still, hope it is fruitful for you, right? Maybe you can ask for some feedbacks.
Anyone ask some feedback?
Actually, the session was very informative. That is, you have started from the basic. So we all know the terms, but it was much more clarified. Thank you, sir, for the session. It was very nice.
Good afternoon, sir. Sir, I am not from a computer science background. Even then, I can understand some of the things and I can learn some of the new information from this. Okay, thank you, sir. Very informative and very wonderful session. You have handled it in a very wonderful way. Thank you.
Thank you, sir, for the wonderful session. Now we have our lunch break. Session 2 will start at sharp 2 p.m. Lunch for offline participants will be served at canteen. Thank you.
ശ്രദ്ധിച്ച് ചോദിച്ചിട്ടുണ്ട്.
കേൾക്കുന്നുണ്ടോ? ഹലോ.
Good afternoon. Participants, please note, session 2 is about to start. Our topic is generative AI models for image analytics, autoencoders and GANs.
So dear all, before starting with GANs and autoencoders, I would like to familiarize with you two tools where we can easily do machine learning and deep learning stuff without knowing Python data. Okay. So if you have your data, you can actually utilize that data for directly into these two tools, and you can perform the machine learning task. Okay. So I'm using the same data set for two experiments, one in a machine learning way and other in a deep learning way. Okay. And what is the actual difference we find in machine learning and deep learning? The first one is we need a dedicated feature engineering for the machine learning, and that feature engineering part is automatically done by in the deep learning. എക്കോ കേൾക്കുന്നുണ്ടെന്നാണ് ഓൺലൈനിൽ നിന്ന് പറയുന്നത്. Is it okay now from the online side? Yes. Okay. So this experiment is actually a binary classification problem. That is, we are having two group of images. One is a collection of images of lemon, and another is a collection of melon, whatever. Okay. So first we can actually observe the data. These are all collections of what? Lemon images. And these are all collection of melon. Okay. So I'm naming it as a lemon melon classification problem, as we are having the data of lemon and melon. So after observing this data, what is your thought? What is the feature I can actually extract from this to distinguish between lemons and melon? Simply we can directly go for color. Right? One is actually having a yellow shade, right? And the other one is having a green shade, right? But the problem here is we are having the images with different dimensions, right? If you take a pixel, it will be having three values, right? If the image is of size 10 by 10, image is of size 10 by 10, how many pixels will be there? 100 pixels. And each pixel is having three values. So how many values will be there for representing a single image? How many values? 300 values, right? But if the images are of different size, if it is a 100 by 100 image, it becomes 30,000. But we always need a vector that represents every image in a fixed length vectors, right? If one image is representing as 300 values, every image should represent as what? 300 values, right? So how do you tackle this issue? How do you tackle this issue? We can scale it into a single dimension, right? Everything can be scaled to a particular dimension, then we can take the pixels. But here also, the objects are actually presenting at different locations, right? The object where the lemon or the melon is present at different regions of the entire image, right? So for maybe the initial 100 values will be green, rest of them will be white, right? So that kind of position issues also there, right? So simply scaling the image will not solve this problem. But we can see that in the images, in melons, we are having the majority pixels as green, right? And in lemon, the majority pixels are yellow. So what will happen if we take the average of all those? It will tend to the majority one, right? It will tend to the majority one, right? So we can conclude that if you take the average of all pixels within an image of melon, the average value will be somewhere there up to green, right? And the case of lemon, we can see that the average values will be somewhere there to yellow, right? So in this manner, what we can do, every image can be converted into three values, three features, right? Right? So what is the step we need to follow? Take one image, find the average value of all the pixels, keep that average three values as what? The features for a particular image, right? So by following this procedure using Python, I have created a curated data set. You can see this, right? The actual images are the raw data. From that raw data, I have created one curated data. Along with that, I am keeping the class of that image. And where can I get the class of that image? The folder name itself is giving the class, right? Right, the folder name itself is giving the class. So while writing the Python program, what should be the structure we need to follow? We have to iterate through the dataset folder, and within that, we have a lemon folder and melon folder. So after getting into lemon folder, I iterate through each image, and we need to calculate the average of all pixels. And for finding the average of all pixels, you can use a library called OpenCV. What is that? OpenCV. After finding the average, keep that as a list and append the folder name also to the list. So how many values will be in the list? Average of R, average of B, and average of G. Along with that, the folder name. So after iterating through all the images, you will have multiple lists which is having four values, right? So you have to keep it as a single list and convert it into a pandas data frame, right? And that output is actually saved like this in a CSV file. So here, each row represents one image and each column representing R, G, and B averages of each image pixels. Then finally we have the class. Okay, so if you have a data set like this, you can make use of a tool called Orange. Okay, Orange. So there is no need for explicitly writing a program for the machine learning part. Okay, there you can actually upload your data, CSV data. So that simply uploading the CSV data from the folder. You can see this, right? All the data is loaded, right? Loaded, right? So from there, you need to load the data table. What is that? Data table. You need to connect the CSV file to data table to see your data. This is to just see your data. And within this, R, G, and B are the features, and C is the target. What is that? C is the target. So I need to keep that for this. I am selecting the columns, and here everything is actually in the feature list, right? Now just drag this class into where? Target. So we are ready with the data. All the features are there and the target is there, right? Now, usually what we will do, we will split the data into training and testing. For that, use this data sampler, okay, and connect the columns with data sampler, okay, and you can decide what proportion the data need to be split, 80% and 20%, right? Also, if you want to visualize this data, okay, if you want to visualize this data, there are some operations. The scatter plot is there. You can connect with the data over here. You can see the plot of data, right? Here, see all the R and green, red and green features are plotted over here, and based on the class, we have two different colors, right? So these are all lemon, and these are all melon, right? Then, can you observe one observation here? The, why this is happening? All the melons are here and all the lemons are with blue. But one blue observation is actually coming at the region of lemon, right? Right? And this is why we are saying machine learning is always uncertain. Right? Why this is happening? See, in the lemon image, one particular image you can see that this is having majority greens. Right? So by taking the average, it will not tend to yellow, it will tend to green, right? And this type of observations are called outliers. What's that? Outliers. So by neglecting the outlier, the entire data is linearly separable, right? Is that linearly separable? Yes, right? So we can decide upon a model whether it is a perceptron or a multi-layer perceptron, right? Okay. So in the model, you can see the neural network. Can you see that? Neural network. So drag it. Now with this data, I need to evaluate our model, whether it is good or not, properly performing or not. For that, you have a provision called test and score. Okay, test and score. There, you can connect our data 2 times because there is a testing sample and a training sample, right? And after double click on the edge, you need to connect it data samples to data and the remaining samples to testing data. Then you can connect the neural network model with this and you can adjust the parameter within this. See, here it says we have only one hidden layer which is having 100 neurons. Okay, suppose you want to add more hidden layers, you can add like 75, 50, see, right? And you can also change the optimizer, the stochastic gradient descent or ADAM kind of things. Then you can adjust the regularization. Everything can be adjusted on this UI itself. Okay. Now, after clicking on test and score, you can see that you are getting a class accuracy of 100%. Right? And if you want to visualize the result as a confusion matrix or something, you can take this confusion matrix and connect it with the results. Then you can see the confusion matrix like this. Right? So, how easy it is? We have taken only less than 10 minutes to build a machine learning model, right? We need not to go behind Python. We need not to go behind the errors happening at the Python, the parameter optimization, visualization, everything can be done in a single stretch and it is more understandable way, right? The pipeline itself is actually providing a good understanding of how the flow is happening, right? So, by teaching machine learning in classes, instead of Python, try to use this, right? If you are experimenting with some models, try to demonstrate that concept with this particular model. Okay. See how much time you take to explain PCU. Principal command it will take a lot of time, right? But with this, we can actually demonstrate it in 5 minutes. Okay. So try to use this kind of smart tools. Okay. Right? So keep it mind orange. Okay. And this is very useful for the teachers who are teaching in +2. So when you conduct any program for teachers in school level, you can introduce this tool for them. Okay. And see here the data is actually a curated one, right? We cannot directly supply what the images of lemon and melon to this particular pipeline. We have to do the feature instance separately. Then only we can view this, right? But there is another amazing tool, and this is that online tool called as teachable machine. Okay. After understanding this, you will, after knowing this, you will understand how the students are doing. Okay. See, most of the time when you go for project presentation or project evaluation, I'm sure that 90% of the projects involved is right? Convolution method. How much time you need to build a convolution method? Or not you, for students. How much time they need to spend? If they have data, 1 hour, I would say it's 2 minutes. 2 minutes needed for building a CMS with all evaluation matrices, plots, results, and finally with an application. Here I'll show you. See, count the time. It's 2:33. Okay. Started. I'm selecting image project, uploading my data. The lemon images, all the lemon images. Give it the name as lemon. The other class, melon. Upload the images. All melon images. Train the model. Training over. Upload one image. It's melon. What is the time now? Exactly 2 minutes. 1 minute. Right? Now you are thinking about the project reports are done, right? The advanced under the hood. The confusion metric, the accuracy plot, the loss plot. And if a student want to make it as an application, export the model, he will get JavaScript, he will get Python code, he will get mobile application code. In 30 minutes, they will ready with 3 kind of applications. See, you are giving marks for this 30-minute effort. And if they are demonstrating this application itself, you won't understand, right? If they claim like they build this application, will you understand that? No, right? This is what I'm saying. The students are very much smart. ഈ ആപ്ലിക്കേഷൻ ഞാൻ കണ്ടത് തന്നെ ഒരു ഹാക്കത്തോണിന് പോയി ജഡ്ജ്മെന്റിൽ എടുക്കുന്നതാണ്. And there are a lot of sites called, have you heard about Lovable? No. With Lovable, in 10 minutes, you can build a complete AI product, a complete AI website. Right? So, this is the pain point we have to stress. Right? We have to be more smarter than our students. We have to find all the tools which is actually going to transform the space. Okay. So, I thought of showing this because it will be a miss otherwise. Okay. So keep it back. These two tools are very amazing tools, right? Even for your research purpose, you can actually make use of this. Suppose if you want to compare 10 models for a particular data set, how much time you need? A lot of time, right? We have to write 10 programs separately, right? See, in that orange, so I just closed it. See, we loaded the data, corrected it first, yeah, yeah. Then data sampling is doing, yeah. Then use this test and score, connecting 2 times. Okay. Now, see, here I have KNN, decision tree, random forest, gradient boost, support vector machine, logistic regression, layer base, ADA boost, 1, 2, 3, 4, 5, 6, 7, 8. Neural network, again, stochastic gradient. Okay. See, I'm connecting layer base, KNN, see the comparison of all 10 models are there. What are these? AUC value, class accuracy, F1 score, precision, recall, everything is there. Right? And if you want to get plots, see, confusion matrix you can connect. You will get the confusion matrix of KNN, naive base, tree, random forest, gradient boost, support vector machine. Everything will be on a single stretch. If you want to plot this ROC curve, see, you can see the plots of ROC curve. Everything in a single click. See, think about the effort you need to put in Python for creating these results, right? So try to use smart tools rather than hard work to do the smart works. Okay. And there is one more tool I can give you as a suggestion. If you are obsessed with Python, if you want to do it in Python, then there's a tool called PyCaret, 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 PyCaret. Okay. There you can do the same thing in 2 or 3 lines of code. Okay, you can do all visualizations, all comparisons, all automl stuffs in 2 or 3 lines of code with PyCal. You only need to load the data, set an experiment, evaluate it. 3 lines of code. It will get completed. Okay. And in PyCaret, you can do classification, regression, time series analysis, a lot of stuff are there. Okay. And in Orange also, we have provision to do deep learning. There, here something called options, and we have add-ons here in Orange. There, if you want to do bioinformatics, explainability, image analytics, geospatial analysis, text spectroscopy, a lot of options are there. If you include any plugin, you can deal with that particular domain. Okay, in a very easy way. So this is a very powerful tool. And one other tool that comes in this class is called Weka. Maybe you have heard about that, right? WEKA. And there is something called a rapid miner. RAPID MINT, a rapid miner. So So we can start with autoencoders, right? So we have learned a lot of things, right? Yes. Try to practice it, then only you will understand its impact. Okay. While taking the classes also, you can actually take the laptops and demonstrate with the projector. Then it will be very clear for them. See, if you simply talk about linearity and non-linearity, they won't understand, right? But if you simply demonstrate with a data set which is a linear and non-linear behavior. From the plots itself, they can actually understand what is a linear data and what is a non-linear data. Okay. So the mystery of autoencoders unraveled. I would say this is one of the most interesting deep learning model, deep learning generative model. Personally, my favorite because we can do a lot of research with this by tweaking in a small way. We can utilize this autoencoder for different applications, and there is something called novelty of the model, right? Novelty of your research that can be easily done with this autoencoders. Okay, so autoencoders are coming under generative AI part, right? And what is the mathematical intuition behind a machine learning? If probabilistically we define machine learning, what is happening in machine learning? This is the another gap we have. If someone is needed to explain machine learning with probability, how will you explain it? What is actually happening with switch? The pattern. Okay. So in discriminative AI, particularly machine learning models, we will be having a data D where we have a set of features and labels, right? In a mathematical perspective, okay, in a mathematical perspective, this X is a subset of an n-dimensional Euclidean space, right? And X is a subset of n-dimensional Euclidean space. That is, each xi, or this is capital X, each element X, element of capital X, is a vector composed of n features, right? A vector composed of n features, and this y is actually a subset of real numbers. Okay. In the case of regression, it is a group of real values, or it can be a collection of discrete classes. Okay. So whatever it is, in machine learning, what we are doing is we are trying to find a function phi. We are trying to find a function phi, a multi-dimensional or multivariate function phi, which takes the input x1, x2, etc. up to xn and maps it into a particular y value, right? Maps it into a particular y value, the target value, right? So ultimately, we are given with x and y. We have to find a phi that maps from x to y. And what is the criteria for finding that phi? What should be the peculiarity of that phi? Minimum phi which gives the error between y and phi of x. The actual target, the actual value, and the predicted value. The difference between actual value and predicted value ഏറ്റവും മിനിമം കിട്ടുന്ന രീതിയിലുള്ള എന്തായിരിക്കണം കണ്ടുപിടിക്കുന്നത് ഒരു ഫൈ ആയിരിക്കണം കണ്ടുപിടിക്കുന്നത്, right? This is the mathematical understanding of a machine learning task, right? This is how we have to explain machine learning in a mathematical perspective. So this is what I asked. How will you define the same thing in a probabilistic way? In terms of probability, how will you define machine learning? See, here also we are given with a data, right? We are given with a data which have x, a multivariate data, and a target value y, right? In mathematics, we call it as variables, right? Or we call it as features, right? But in probability or in statistics, we call it as random variables. We call it as random variables. Okay? And we will be having another random variable. Random variable y. Right? So, for the sake of explaining this instance, I have two random variables, x1 and x2. And this implies I'm tired. Okay? I'm tired or not. So this random variable can have two values, either 0, 1. 0 means I am not tired, 1 means I am tired. So clear? And the other random variable, is it sunny or not? Is it sunny or not? 0 means it's not sunny, 1 means it is sunny. And the target value is also having two possibilities, yes or no. I will play football or not. Okay? So, I need to find a relationship to decide whether I should play or not, given whether I am tired and today is sunny or not. Right? So, in that perspective, how can I decide? How can I decide whether I will play football or not? There, what we are finding is we will find the probability of y being, that is what? Play. Right? Play being what? Yes, provided tired equal to 0, tired equal to 0, and sunny equal to 1. Right? What is that? If if I am tired and it is a sunny day, what is the probability of I am going to play football? Right? And I will also find the probability of playing equal to know whether tired equal to 0 and sunny equal to 1. So to decide this, I have a past data, right? And from past data, I can find the probabilities of this cases. And this probability is actually called as conditional probability. What is that? Conditional probability. Right? So that probability is actually taken from a probability distribution. Okay? Probability distribution. So in machine learning, in a probabilistic way, we have to say that we have to find a probability distribution that maximizes y given x. Right? We have to find a probability distribution that maximizes y given x. Xന്റെ വാല്യൂ ഇങ്ങനെയൊക്കെ ആകുമ്പോൾ y ഇന്നതാവാനുള്ള പ്രോബബിലിറ്റി എന്താണ് എന്ന് നമുക്ക് പറഞ്ഞു തരുന്ന ഒരു പ്രോബബിലിറ്റി ഡിസ്ട്രിബ്യൂഷൻ ആണ് നമ്മൾ അവിടെ എന്ത് ചെയ്യുന്നത് കണ്ടെത്താനായിട്ട് ശ്രമിക്കുന്നത്. സോ ഇൻ എ മാത്തമാറ്റിക്കൽ പെർസ്പെക്റ്റീവ് വി ആർ ഫൈൻഡിങ് എ multivariate function, but here we are trying to find out a probability distribution that holds a particular conditional probability. So we are focusing on conditional probability here. Provided these are the features, what is the target? What is the probability of target being this? Right? Are you getting that point? Yes. But when it comes to generative AI, the thing is different. Okay, when it comes to generative AI, the things are different. And how can we understand generative AI? Here, see, the task is generate something, right? The task is generate something. Okay, fine. So, just think about some images of dog. Okay, just think about some images of dog. Is it clear? Yes. And think about some images of cat and fox. Usually it will be cat, but for this example it is fox. Right? So there will be a variety of dogs, right? Some will not seem like actually dogs. Some seems like cats. Right? And but some majority of the dogs are having the same property, right? And some is having entirely very different properties of that of dogs, right? So consider all the dogs are mapped into a numerical value. All the dogs are mapped into a numerical value, right? So, if you look at a point in the number, right? Okay, I'm telling that for being a dog, the maximum chance is 8. If I'm mapping a dog into a numerical value, right? For being a dog, if it is 0.8, we can definitely say it is dog. Is that clear? Right? So there will be some extremes also, right? Some may seems like what? A cat, and some may seems like a fox. Some may seems like fox. Is that clear? Right? Like you are doing category like Siberian, very husky, right? Husky, yeah. Husky seems like a wolf, right? Right? And some dogs are like cats, but majority of the dogs are actually having the property of a dog. So here comes the huskies, here comes the cats, and here are the actual dogs. So it shows a probability distribution, right? So if it is 0.8 or 0.5 or 0.11, it can be a dog, right? And if I am mapping every fox into a numerical value, right? For being an actual fox, the value should be 1.5. The value should be 1.5. But some foxes are like what dogs do, right? Some foxes are actually having the properties of dogs too, right? So these are two probability distribution P, and this probability distribution is Q, right? In generative task, I don't know the probability distribution of data. I have images of dogs and I have images of tasks. So this is our intuition. This is our intuition that it lies as two different probabilities, right? So what is the need of generative models? I need to generate a dog or a fox, right? So if I'm generating a dog, right? If I'm generating a dog and that dog is white. If I'm generating a dog, that dog is white. And the actual dog is D. The actual dog is D. That is, this distribution is represented as D. Right? Then I could say Y is a dog. The probability between this Y and X should be massive. And what kind of probability it is? This is called as joint probability. What is that? This is called as joint probability. Previously it is conditional probability. If Y is this, if X is this, what is the probability that Y could be this? But here the probability is entirely different. This probability is called as joint probability, and this gives what is the probability that X and Y, the two random variables X and Y, behave similarly, right? Or what is the probability that the correlation between X and Y is very much high, right? That is what the chance of occurrence of X along with Y is very high, right? So if both are occurring, with a high probability, I can say that Y is having the features of what? Yes. So Y would be definitely what? A dog. Is that clear? So we have to generate such Ys provided the probability, the joint probability between Y and X should be maximum. Are you getting it? Is that clear? So this is the whole idea of generative models. In discriminative models, we are trying to maximize the conditional probability, but in generative models, we are trying to maximize the joint probability between two random variables. Is that clear? Yes. Which so most of the generative models are trying to push one random pick from a probability distribution to an appropriate pick. Sometimes, as we are not having the idea of a probability distribution, what will happen if I randomly pick? Sometimes it may be child, sometimes it may be a fox, but we want to get a dog. Right? We want to get a dog. So we have to adjust our technique through training in such a way that whenever I want to pick a dog, I should get a dog. Otherwise, I should get a fox. Right? So different strategies are there for this. And the first strategy we are going to discuss as what? Auto encoders. ചായ കുടിച്ചിട്ട് കണ്ടിന്യൂ ചെയ്യണോ ഓർ ഓട്ടോ എൻകോഡേഴ്സ് തീർത്തിട്ട് ചായ കുടിക്കണം? ഫുഡ് കഴിച്ചിട്ട് ചായ കുടിക്കാൻ ടൈം ആയതാണ് ഞാൻ ഉദ്ദേശിച്ചത്. വാട്ട് ഡു തിങ്ക്? പറഞ്ഞു ചായ കുടിക്കണം എന്നുള്ളത് കൈ നോക്കിയാൽ പെട്ടെന്നാണ് ടു മേക്ക് ദ ഡിസിഷൻ. 1, 2, 3. മെജോറിറ്റി വോട്ടിംഗ് ആയില്ല. സാർ എന്താണ് ഇപ്പൊ ബ്രേക്ക് ചെയ്യണോ? തീരെ ഇത് തീർത്തിട്ട് പോകാനാണ് ഇവർ പറയുന്നത്. ഭയങ്കര എന്തൂസിയാസ്റ്റിക് ആയിട്ടിരിക്കുന്നത്. Okay. So auto encoders are not a complicated architecture. Okay. It is like, see how you are preparing for an exam. Okay. How will you learn an essay from a textbook? Suppose you have an essay to learn. Okay. Maybe the Second World War, some social studies. Okay. And it spans across 3 or 4 pages, right? Second World War is the most difficult essay I ever remember. We have to learn through pages, okay? And how this process is actually happening. We are learning through these 4 pages, but are you keeping the entire word sequence in your brain? No. Right? We are not keeping the entire brain sequence in your brain. Right? But you are able to reproduce the same thing in the answer papers. Right? Exactly same as that of textbook. But still, what do you mean by this exactly? It is not the words, but the context. Right? But the context. Right? So, how your brain is actually storing that essay? That should be in some encoded form of actual text, right? We don't know the encoding, but we are doing it, right? We are doing an encoding on that text. Then we are keeping that in our brain in some representation. And at the time of examination, we are actually decoding it back to generate the actual text, and we are writing on the paper. And the evaluator will check for the context only, right? He will not check for the actual sequence of words, but he will check for the preservation of context, right? That context need to be preserved. So the same process is actually happening in encoder decoder models, right? We have an actual data X, and that X is encoded into a particular form called XZ, right? And after encoding, that input vector is called as what? A latent vector. What is that? A latent vector, right? And this latent vector is again decoded back to get an output. An output. But as we are not aware about this encoder and decoder, we don't know what is happening in encoding and what is happening in decoding, right? Right? So there is no guarantee that X and X dash is similar, or X dash is preserving the context of X, right? For that, the neural network will help us. Okay? And what is happening with the neural network? First, we will give the input X into the encoder. It will produce some kind of latent representation, and that latent representation is again used for decoding, and we will get some output, what? X dash. If X dash is not similar as that of X, who is responsible for that? The encoding process and the decoding process, right? Who is responsible for that? The encoding process and the decoding process. The encoding is done by a neural network, and the decoder is also done by a neural network. So who is responsible for that? The encoder neural networks and the decoder neural networks. And what is the core of a neural network? The structure, obviously. Apart from the structure, more importance is given to the weights. More importance is given to the weights, right? So I can ultimately say that this architecture is producing an incorrect result X dash because of the incorrect weights in it, right? Because of the incorrect weights in it, right? So what is our objective? Our objective is to correct the weights in encoder and decoder such that the difference between X and X dash should be minimum, right? The difference between X and X dash should be minimum. The difference between X and X dash is actually called as loss. What is that? Loss. So by taking that loss as an input, we need to find a strategy to update the weights in encoder as well as decoder. That strategy is actually called as back propagation. What is that? Back propagation. So the back propagation will calculate the loss in generating the output, and it will particularly use that loss for updating the weights, right? So after doing the same process multiple times, what will happen? The error will reduce and reduce and reduce and reduce. Finally, we can see that the encoder and the decoder pair is generating a very similar X dash to X. A very similar X dash to compare it to X. At that time, we can say that our encoder decoder model is properly learned. Okay? Properly learned. So this is an encoder decoder model, and why it is called as an auto encoder? Because it is an unsupervised learning technique, unsupervised version of encoder decoder. Here we are using the X as an input, and the same X is used for calculating the loss, right? the same x is used for calculating the loss. Is that clear? So there is no y. Usually what will happen? We will give x, we will generate y, and we will compare with the actual y and the predicted y. But here there is no such y. We are using the same x for the loss calculation. Is that clear? Right? So it is an unsupervised learning technique. That is why we call it as auto encoders. Right? Automatically, the encoder decoder model will learn the probability distribution of x. Right? The probability distribution of x. In the probability distribution perspective, what makes the error? Because the encoder is not aware about understanding the probability distribution of x, and decoder is not aware about how to reproduce the output x dash that matches the probability distribution of x, right? So after the training process, together the encoder and decoder will understand about what is the probability distribution of the given data x. Then the x will be placed in one probability distribution. From that probability distribution, it will take it back to the actual one, right? So this is the working of what? Autoencoders. And this particular architecture can be tweaked for different use cases. Okay, so I will explain that part. Here, you know what is encoder and decoder, right? Encoder, decoder, application of autoencoders. See, the first one is dimensionality reduction. Suppose the input is having 3000 feature values. The input is having 3000 feature values, and the output is also 3000 feature values, and in between at the bottleneck we are keeping only 200 euros. We are keeping only 200 euros, right? So ultimately, if the auto encoder is learned properly, what will happen? The autoencoder can represent the data using 3000 values into 200 values, because the other values are not needed for that. So I will tell you an example. See, if so someone asked about the concept of PCA in the morning, and PCA is particularly doing feature extraction. Okay, and what do you mean by feature extraction? See, suppose we have a data like this. Can you switch the height, weight, and length of a toy is there? Okay, and we have to predict the cost. We have to predict the cost, but we don't have a specific equation for finding the cost, right? So I could say that cost is actually a function of what? Height, width, and length. I don't know the dependency between the cost, height, weight, width, and length. But one thing I know, as height increases, as width increases, as length increases, what will happen? The cost of the toy will increase. So, for this particular problem, how many features we have? 3 features, 1 target, right? The question is, do we really need these 3 features? Do we really need these 3 features for this problem? That is the idea of feature extraction. Okay? There, what I am trying to tell us, see, if you consider the toy that can be accommodated in a rectangular prism, then this is actually the length, width, and height. Right? Length, width, and height. consider this base diagonal, and I'm naming it as dB. dB is nothing but root of L square plus W square, right? Right? So if L increases, dB increase. If W increases, dB increase. So instead of keeping L and W, we only need to keep what? dB. Right? Again, if you consider this dB and the lateral diagonal and H, what will happen? This dl is nothing but root of dB square plus H square. And what is this H square, dB square? Root of L square plus W square plus H square. So the impact of L, W and H is captured in a single variable dl, right? So instead of keeping this particular data, we only need to keep what? dl and post, right? So what happened to this? We are converting a three-dimensional data into a single dimensional space without losing its context, right? That is, all the information within a vector need not to be there for representing the context of a data, right? The same thing is happening in the search switch here. The same thing is happening with autoencoders. In the previous example, we have a data which is specified using 3000 sample, 3000 features, and we convert that 3000 features into 201, and that 200 is again gained back to what? 3000. That means the context represented by that 3000 features can be highlighted or represented using that transform 200 features, right? So whatever effect this 3000 features are giving for a problem can be done with the transformed 200 features for the same problem, right? So that problem will be further modeled with only 200 features. So from 3000 to 200, we are reducing the set of features, right? That is what we are calling as dimensionality reduction, right? Dimensionality reduction. Is that clear? So this is one of the application of what? Autoencoders. So if you have a pipeline of machine learning, at some steps, if you are using some dimensionality reduction, replace that traditional dimensionality reduction with autoencoders. Then we can title that paper as an autoencoder driven dimensionality reduction technique for rate tumor classification or X-ray classification, whatever it is. Is that clear? Right. And the second one is this is actually the PCA versus autoencoder. PCA is also a technique for what? Dimensionality reduction. See the clarity of PCA as well as the autoencoders. You can see that with autoencoders, we can actually distinguish the data in a more particular way, right? And the next one is feature extraction. The next one is feature extraction. Suppose you are having an image, right? As I said in the case of Mammootty and Mohanlal, but you don't know how to convert it into features. How to convert it into features. That is, we need a vector for that, right? How will you do that? We can create an autoencoder. As it is images, the encoder should be CNN and the decoder should be CNN. After training the model, what will happen? From the image of Mohanlal, it will convert it into a vector, and from that vector, it can recreate Mohanlal. From the images of Mammootty, it can create a vector. It can recreate that into Mammootty. That means all the important characteristics of that image Mohanlal is captured in this representation, right? And all the important characters of Mammootty is also represented in this small representation, right? And that small representation is distinguishable, then only that decoder can recreate that, right? So that features can be utilized for further machine learning process. Is it clear? Right? That is how we are extracting the features from other kind of data. Is it clear? Right? Now, denoising autoencoders. So this is actually a misinterpretation of denoising autoencoder. Denoising autoencoders is actually having the idea of, see, you have seen an outlier, right? In one of the example, the lemon and melon, and how this outlier is actually occurring. How this outlier is actually occurring. It is actually need to follow a probability distribution, but it is actually moving away from that probability distribution, right? Right? That is why that outlier is happening. But I want to take that outlier into an actual data space. Right? So what I can do with original data, I need to learn a probability distribution. Right? So the encoder and decoder will be tuned to convert one input into its original form from that probability distribution, right? Then what will happen after the training process if I give the outlier as an input? The outlier will also be taken into that particular probability distribution, and then after generating it, it will follow the probability distribution. Then what will happen? One point that placed as a noise will come into the actual distribution of the data. Is that clear? In that way, we can do the denoising part in the data. If you have a lot of noise in your data, you can handle that noise with what? Autoencoders. Okay? And image compression is the another one. See, if the encoder decoder model, after building, we are splitting that encoder and keeping it the sender side and keeping the decoder at the receiver side, what will happen? What will happen? You can have a compression technique, right? Suppose you have an image, you can compress that image with an encoder. Then send it over a communication channel, and at the receiver end, with that representation, you can decode it back and get the results, right? So it will also serve as a what? Compression technique too. And there are some special kind of neural network. Anjali Sopnesh, your mic is on. So there are manually exit and better. Okay. So these are the different types of auto. The previous one are the use cases, and these are the different types of autoencoders. The first one is under complete autoencoder, where the latent space is less than the actual data size. What is that? Under complete autoencoder. And this is what we are calling as over complete autoencoders. Here, what will happen? The latent phase will be larger than the actual phase. What is the need of that? What is the need of that? Why we need to enlarge the data feature space? See, I will tell you an example. See, if you have a data like this, okay, so if okay, is this data linearly separable? Is this data linearly separable? No, but can we make it linearly separable? Yes. How? Yeah, by the Turner trick, right? Since it is a two-dimensional data, we cannot separate it, right? But if you introduce a third feature, okay? If you introduce a third feature for this, that is, the third feature is instead of x and y, we generate z2, which is equal to x square plus y square. That is the square of the distance from center to that point. Right? Now, if you try to visualize this data, what will happen? All the blue points will be in a particular range of Z because all the blue points are having more distance from center, right? And all the red points will be all the red points will be in a lesser height than the blue points, right? Now we are able to find a plane that separates these two regions, right? Right? So some problems are not solvable at one dimension, but the same problems can be solved in some other higher dimensions. So to take it our data into higher dimensions without losing the properties, we can make use of what? The over complete auto encoders. Okay. Switch. So this is stacked autoencoders. We can keep more than one hidden layer encoders and decoders. And sparse autoencoders are special kind of autoencoders where some kind of overfitting will be happening at encoder decoder layers. So to handle that, we will regulate some kind of nodes within the encoder as well as decoder. Okay, and this is one of the major autoencoder model you have to understand. This is the base of generative adversarial network. So this is a very layman perspective intuition. See, if we need to represent an image in the latent space, maybe these are the important features to reproduce that image. The smile, the skin tone, the gender, the beard, the glasses, the hair color are the different features, right? So for a particular image, the autoencoder will find out some appropriate values for distinguishing each image from another, right? Right? Okay. So I can consider this latent attributes as the mean value of each of this feature, right? But to represent the probability distribution of a data, do we really need some more parameters? Is mean or any kind of average is enough for representing a data? I would like to ask a question. Suppose you have two classes. One is having 5 MTech students, and the other class is also having 5 MTech students. Okay, and you conducted machine learning exam for both the classes, right? One class got score 0, 25, 50, 75, 100. The other class got the marks 14, 49, 50, 51, 52. What is the average of both the classes? What is the average of both the classes? Same, right? But can we say both the classes are having same behavior? So to represent a probability distribution, we need extra parameters like variance or standard deviation kind of things, right? Okay. So there is a technical issue while implementing this autoencoders, because autoencoders are only keeping one of the parameter to represent a distribution, right? But this variational autoencoders actually keeps a probability distribution itself rather than a single value. That is, our understanding is that the entire latent space is divided into two parts. The first one will track the mean, and the second one will track the standard deviation or the variance, right? So with this standard deviation and mean, it can actually represent that probability distribution of the data, right? Right? So it can create or recreate the output in a more generic way and with more clarity without confusions. So that is the idea of what variational autoencoder. See, we said the losses are used in autoencoders to generate it, right? So here we use a reconstruction loss of x minus x cap by 2. That by 2 means we are taking the Euclidean distance. But along with that reconstruction loss, we will also consider a loss called KL divergence. What is that? KL divergence. KL divergence will look for the similarity between the learned probability distributions too. Not only the reconstruction loss, but also the loss between probability distribution. Is that clear? Right? It is a normalized loss because it is expecting every loss need to be in between 1, 0 and I. The mean should be 0 and the standard deviation should be I. Right? But at the beginning, the mean and standard deviation will be some random values. But after training it properly, what will happen? This ux and sigma x will converge to 0 and 1. At the same time, the reconstruction loss will also comes to 0. Right? So we have to minimize both the reconstruction loss and the similarity loss. So we will keep track of the reconstruction loss as well as the change in or the loss happening between the probability distribution. So after minimizing the entire loss, what we can guarantee? The reconstruction will happen in a good way. At the same time, the probability distribution among each of the features will also be maintained properly. Is that clear? So that is what we are calling as variational autoencoders. Okay. Now we can have a break. If you come back very quickly, we can actually understand GANs in a more proper way. Otherwise, I need to rush. Okay. Right. So come by 3:45 or 3:50. Right. So online participants, now we are having a break. Please join back by 3:50. I'm audible now? Hello, am I audible now? Yes, okay. So I will repeat from the beginning. So GANs are a kind of generative AI models which is called as generative adversarial network, and this is particularly based on a game theoretic theories. Okay, game theoretic theories. And there is an adversarial kind of training happening in GANs. And adversarial kind of training means a monitor training is happening at GAPs. Okay, or it can be called as a unsupervised learning technique which uses a supervised loss function. Unsupervised learning technique which uses a supervised learning loss function. Okay, so to relate the working of GAN, you have to consider this discriminator as a police, discriminator as a police, and the generator as a thief. The generator want to create realistic realistic fates, right? He want to create realistic fates, and the discriminator wants identify output by a generator is real or it is a game between a maximization game between the generator. We can say that it is a game between police and thief. Right? Ultimately, what we do as a user, what we do, we take control of the generating thing. And for that, we are utilizing the capability of a police. Right? So what I will do is, first I have a group of real images and right, a random fake images. Then I will train the discriminator, the police with this, and it will be capable of understanding what a real image and a fake image. Right? Real image and a fake image. Now I will let the generator generate some things. But the problem with generator is that he don't know how to make things. He don't know how to make things which seems real. Randomly go with some strategy. He will randomly pick some data from a random possibility and he will generate some outcomes. Right? Then this outcome goes to the discriminator. So what discriminator will identify these targets as fake because he is capable, right? So after identifying this thief is actually observing the policeman. So the thief is understanding that what I have made is fake and it is detectable by the discriminator, right? So what he will do? The laws generated by the discriminator, he will update his ways. That is actually updating his strategy. So the next time, what he can do, he can generate some outputs which is similar to what real, because he's actually updated his strategy, right? So again, he will expose that to police and he will find out that that means with problem, right? So what the thief can understand how my application can make somewhat a kind of real image. So again, it will observe the loss of the user. That loss will again will be used for updating the strategy of what generator, right? Generator. So what will happen? Iteration go for long, but the thief will be able to generate outcomes which are very realistic, and at that time the policeman got fooled. Okay, at the point where the policeman got fooled, what will happen? He will fix the strategy. And at that time, he can now generate any images which seem or any outputs which seem to be real. That is, from a random probability distribution with the adversarial laws, he is actually able to find out the actual probability distribution of the data. Right? The parameters that describes the actual probability distribution of the data. Right? This is what happening in GANs. So I will repeat. First, we have a generator and a discriminator. The ultimate goal is to make the generator able to create fakes which seems real, but he don't know the strategy. So how to learn that strategy? By using a adversarial game. By using a adversarial game. And what is that game? He will generate some outputs, and that output will be exposed to the adversary. And who is the adversary here? Police is the adversary. And that adversary is capable of identifying whether the given image is fake or not. Okay? Now, after exposing the output to the adversary, he will detect it as fake. With that feedback, what will happen? The generator will update his strategy. Updating the strategy means he will update its weights. Right? After updating the weights, what will happen? It will again generate another set of fake outputs. Right? And that fake outputs is again given to the police. Right? But previously, it found that fake images with high probability. Now the probability becomes less. So with that information, again the generator will update his strategy, and this will continue for a long number of iterations. And finally, what will happen? The generator will update his strategy and strategy and strategy. Finally, he will be able to make some fake images which seems really realistic. At that time, what will happen? The police will get fooled. Okay, the police will get fooled. Is that clear? But one more correction I want to make here is, after doing this process, again we will train the police, because we need to make the generation more better, right? So after fooling, at one point, the police will get fooled, right? At that point, we will again give the real ones and one which seems like real as fake, and will again train the police. So what will happen? The police become more capable of distinguishing it, right? Then this will repeat again. So after doing this loop, what will happen? The police will get more capable. At the same time, the thief will also become more capable. At one point, we will get all realistic ones. At that point, we will stop the training. Is that clear? So this is the strategy that is happening in gaps. Okay, fine. And I think these theories you can go through the slides. Okay, so this is the one. See, from the noise, the generator will generate some kind of X dash, and the discriminator is already trained with the fake and real. Then it will find the feedback from discriminator to update the generator. This will happen for multiple times, and finally the generator becomes what? More capable of generating real samples, sorry, fake samples, which seems real to others. Okay. And see, this is the loss function we are using in GAN, and this is based on what? Min-max game theory, and it is having a similarity between Jensen-Shannon's divergence. We have listened about KL divergence, right? Similar to that, there is something called Jensen-Shannon divergence. This is actually the entropy equation. Have you heard about the entropy equation? Yes, it seems like entropy equation, right? The probability, the expectation of log p minus the probability of log of 1 minus p, right? And there are some interesting GANs to show. See, this is what we are calling as a super resolution GAN. Okay, the GANs are mostly used for super resolution because it is one of the major problem ever faced in image processing. From a low resolution image, without losing the clarity of the image, we need to make it into high resolutions. So for that, you can make use of this. Then cycle GAN. This is actually used for converting the style of one image to another images. Okay. See, these are the cycle GANs. And one thing I want to show here is, see, previously we thought about an unsupervised version of a GAN, right? Suppose you want to do a denoised image, denoising process. Suppose you want to do a denoising process. Okay, then how will you create a GAN? Usually we think in a way that, see, this is one point you have to keep in mind while deciding GANs. Okay, see, first I will have a discriminator. I will have a discriminator. Then I will give a set of images X, that is noisy one, and X, which is real images, right? So now the image is capable of what? The discriminator is capable of understanding whether it is noised or denoised, right? Now I'm giving an input to the generator, right? A random input, and I will map it with some random vector. Then it will generate some output, right? And it will give to discriminator.
കഴിഞ്ഞ ദിവസം ഇതെന്താ ഇവിടെ നിന്നൊക്കെ സൗണ്ട് വരുന്നേ
It is noise or denoise. In a very simple perspective, this architecture is fine, right? Right? But see, one point you have to think is, suppose your images is having apple, banana, orange. So you have the noised version of apples and denoised versions of apple, noised versions of banana, denoised versions of banana, apple version, noised versions of orange, and denoised versions of orange. Right? Now we use this architecture, but on giving a new image, the new image is an orange. Okay? And it is generating a noised orange. But if it is generating a denoised apple, what will be the output of this simulator? It will say it is true. Right? Are you getting the point? The discriminator only looking for whether it is noised or denoised. It is not looking for the structural pattern within the image, right? Are you getting it? Are you getting it? Yes. So if you give the noised image of an orange and you are getting a denoised apple from the generator, if you submit that output into discriminator, it will say that there is no loss in it. Right? There is no loss in it. Right? So is our architecture correct for a supervised purpose? This is the case of segmentation. This is a case of a particular deblurring, super resolution. Everywhere we will encounter this.
Mission 2K25 documents.
So what is the solution for this? The solution is that while training the discriminator, what you have to do is you have to create pairs of fake. That is, if it is fake, if it is real. For fake, the denoised apple and denoised banana is noised apple and denoised banana is a fake. A noised apple and a denoised orange is a fake. Right? And for real, we have to keep a noised apple and denoised apple. A noised banana and a denoised banana. A noised banana and a denoised orange is fake. A noised orange and a denoised orange is real. So, the same time, the discriminator need two channels of CNNs, right? So the entire DNN, so the entire discriminator is actually having one CNN layer and another CNN layer which inputs a pair of inputs, and by combining this we can ultimately give an output 0 or 1, 0 for fake and 1 for real. Is that clear? So GAN is only a framework. GAN is only a framework. You have to design GANs for your own needs. According to the use cases, you can actually design your discriminator, design your generator. All these things can be done. Is that clear? So think about GANs as a generic framework for creating generative models using adversarial training. Okay, right? So along with these slides, I will also share the codes in Python. If you get time, just go through it and try to practice with all the things that are described in the slides are mentioned in the codes too. So you can easily understand it. Otherwise, you just need to copy each block into ChatGPT. The ChatGPT will explain what is happening with that. Then you can understand it. Okay. Right. So thank you for patiently listening for this much time. I think we have to wind up as the college was starting soon. Okay. So online participants, do you have any questions to ask? Anjali, are you asking any questions? Can you just type on the chat box? The chat window no now. Any questions from the participant side? Yeah, slides will be shared. Yeah. I think we can wind up if there is no questions from the participant side. Offline participants, is there any questions? to ask? So you have to go through this, right? This, consider this as only a kickstart. Okay, kickstart for your journey to this session, particularly in that to make the things clear for you. It's now your duty to build upon this. Okay, right? So we have a lot of resources, but while creating these slides, we don't have ChatGPT or AutoInverse or anything. That means any AI tools was not there. We have to go through the text, we have to go through the blocks, then actually we created all these slides. But it is very easy now. If you have a confusion about a particular thing, you can just ask in the ChatGPT. So make the fundamentals and theories very much clear so that you can actually build up these things very easily. And the strategy I'm following is challenge yourself. എനിക്കൊരു പുതിയ കൺസെപ്റ്റ് പഠിക്കണമെങ്കിൽ ഞാൻ ആദ്യം ചെയ്യുന്നത് ഏതെങ്കിലും ഒരു ടോക്ക് വരുമ്പോൾ ഐ വിൽ കമ്മിറ്റ് ബ്ലൈൻഡ്ലി. എനിക്ക് അറിയില്ല എന്നൊന്നും നോക്കില്ല, അതങ്ങ് കമ്മിറ്റ് ചെയ്യും. പിന്നെ അത് നമ്മുടെ ഒരു ഒബ്ലിഗേഷനായിട്ട് മാറും. കാര്യം ക്രൗഡിൻ്റെ മുമ്പിൽ പോയി നാണം കിടാൻ കഴിയാത്തത് കൊണ്ട് നമ്മൾ എന്ത് ചെയ്യും, ആ രീതിയിൽ നമ്മളത് പ്രിപ്പയർ ചെയ്ത് പോയി ചെയ്യും. അതുപോലെ യു ജസ്റ്റ് കമ്മിറ്റ് എ ക്ലാസ് അറ്റ് ദ കോളേജ്, ഏതെങ്കിലും ഒരു 5 days കിട്ടുന്ന ഒരു ഇൻ്റർവൽ ടൈമിനോ ജസ്റ്റ് അനൗൺസ് ആൻഡ് ടേക്കിംഗ് എ സെഷൻ ഓൺ ദിസ് പർട്ടിക്കുലർ ടോപ്പിക്. ഇഷ്ടമുള്ള ആൾക്കാർക്ക് ഏത് ക്ലാസ്സിൽ നിന്നോ ഏത് ഡിപ്പാർട്ട്മെൻറ്റിൽ നിന്നോ വന്ന് നിങ്ങൾക്ക് എന്ത് ചെയ്യാം, അറ്റൻഡ് ചെയ്യാം. സോ ഇറ്റ് വിൽ ആക്ച്വലി ഗീവ് ക്ലാരിറ്റി ഓൺ ദ ടോപ്പിക്സ് as well as you will get confidence on what you have going to present and what you have learned. And you will get a lot of feedbacks from others. അത് വെച്ചിട്ട് നിങ്ങൾക്ക് ഇമ്പ്രൂവ് ചെയ്യാനും പറ്റും. ഈ സ്ലൈഡ്സ് തന്നെ ഓരോ ക്ലാസ് കഴിയുമ്പോഴും മാറിക്കൊണ്ടിരിക്കും. ആ ക്ലാസ് എടുക്കുന്ന സമയത്ത് എനിക്ക് ഫീൽ ചെയ്യുന്ന ഗ്യാപ്സ് അടുത്ത ക്ലാസ്സിൽ ഉണ്ടാവും, ഫില്ല് ചെയ്തിട്ടായിരിക്കും വരാം. ഓക്കെ, സോ താങ്ക് യു.
Offline participants, please give feedback for the session.
First of all, thank you very much, sir, for giving such an opportunity and this much knowledge. It was actually very understanding. In my point of view, it was very understanding. We can connect with real-time applications. All examples were real-time. I was thinking like we are not giving that much examples in our class also. After your class, I am confident and I can integrate examples, more examples from your class and all. It was very knowledgeable and understanding also. Thank you very much. Also, I am thanking FISAT institution for giving such an opportunity to attend offline class. Online class, we know we sometimes sleep and all, but offline class we can understand more things and all. I thank you both sir and institution for this class. Thank you.
Thank you, Miss.
Thank you, sir, for a wonderful session. Appreciation is just like water is to plant. That is my point of view. And I appreciate, sir, for this wonderful sessions. And I was able to attend from the beginning till the end. It was actually very fruitful session. We are expecting much more knowledge from your side. You are really a resource person itself. A lot of resources. Thank you, sir.
Thank you, sir, for the informative sessions. Participants, please note, tomorrow onwards, our sessions are online. Thank you all.